An exact knowledge of the signals and what to do when you hear them will save your life. There are four warnings. The red, the grey, the black, and the all clear. First, the red warning. Sounding the red warning. It means that there is imminent danger of an attack. This is the grey warning. It means that fallout is expected in an hour's time. Where sirens have not yet been provided, the grey warning may also be given by church bells, or in Scotland, where church bells are not in common use, by word of mouth or by whistle. These are maroons. They indicate the black warning. It means there is imminent danger of fallout in your area. Where maroons have not yet been provided, this warning might be given by a gong or whistle sounding one long and two short notes, which is the Morse note D. Finally, this is the all clear. It means that there is no further threat of air attack or fallout and that you can leave your place of shelter. The all clear may also be given by civil defense workers or the police. Now, what to do when you hear the signals? First and most important, you should take cover immediately if you hear this red warning. If you are outdoors and cannot get home in 4 or 5 minutes, take cover in the nearest building. If you are caught in the open, take any available shelter. But if there is no obvious cover, you should lie in a ditch or a depression in the ground, covering the exposed skin of your face and hands to protect them from the heat flash.
Air attack is approaching this country now. Go to shelter or take cover at once.
If you are driving a car, park immediately. But do not leave your car in any place where it might obstruct the many vehicles that will be engaged on urgent rescue work. Park it off the road if possible. Find the nearest cover, and if there are no buildings, lie flat in a ditch or depression. You should always give shelter to anyone who is caught in the open near your house when the warning sounds. They may have no other protection from the attack.
An air attack is approaching this country now.
If you are visiting, take cover wherever you are, unless you can get home in 4 or 5 minutes. If you are at home, you should turn off the gas and oil supplies and disconnect your electric heater. Damp down any fires with earth or sand and close all your windows. Then take cover in your fallout room or shelter. Now a grey warning, with fallout expected in an hour's time. If you had only taken temporary cover, you should go home, if you can get there quickly. If, however, you are still in the open, look for safer and more comfortable shelter as quickly as possible. If you are visiting and have taken shelter, go home if you can get there quickly. But if you can't, stay where you are. If you are at home, finish any last-minute preparations and then go to your fallout room. Finally, a black warning, which means fallout is imminent. If you are still outside, find the best available cover. If you are visiting, take shelter where you are. At home, go at once to the fallout room when the black warning is heard. Remain there. Keep the door of the room shut, as there will be plenty of ventilation from around the door. Everyone must realize there is the possibility of an attack taking place before any warning can be given. If this happens, the first indication would be the flash of heat and light produced by the explosion and lasting up to 20 seconds. This would be followed by the blast wave. Whatever happens, you must not look in the direction of the flash. It could blind you. If you are caught in the open by the attack, fling yourself on the ground instantly, wherever you are. Do not move until the blast wave has passed. If you are at home or visiting, move instantly away from open windows or doors and take cover behind the nearest solid protection. When the heat flash passes, go to your fallout room if you can reach it in a matter of seconds before the blast arrives. If you can't, you should stay where you are until the blast wave has passed. It is unlikely that an attack will come without any warning, and the warning system is aimed to give notice of the threat of attack and of fallout so that you have time to take cover. Instant recognition of the warning signals is vitally important. So let's read it. The red warning. Imminent danger of attack. The grey warning. Fallout expected in an hour. The black warning. Danger of fallout imminent. The all clear, no further danger of attack or fallout. Warnings will only be cancelled by the all clear, or by word of mouth from the police or civil defense wardens. Once a warning has been given, there is danger, and you must not expose yourself needlessly. From now on, you must listen for and take immediate notice of warning signals. For your own safety, you must follow exactly and promptly any instructions given by civil defense workers or the police. The warning system will save your life. You must not only know what to do in the event of a nuclear attack, you must also know what action to take immediately after. Your safety may depend on prompt action taken during the short time that may elapse before fallout arrives. As soon as the heat and blast waves have passed, one of you should leave your fallout room and find out the extent to which the house has been damaged. Fire will be the most immediate danger. You should go round the house and put out any fires that the heat may have started before they have a chance to become established. Call your family to help you if necessary. Fires can be extinguished by using mains water if still available. You must turn off the stopcock as soon as possible, so as to prevent the possibility of contaminated water entering the system. You must at the same time turn off any water heaters and shut down your boiler. To prevent valuable clean water from being used for flushing, you should tie up the ball cock in your WC system. From now on, conserve your water supply. Having dealt with the inside of your house, you should now put on gumboots or cow shoes, a coat done up to the neck, a hat or headscarf, and some gloves, before going to see what needs to be done outside. This must be done, regardless of the unknown risk of fallout. Make sure your house is safe from any fires which may have started nearby, or fires which may spread from other houses. When you have dealt with your own home, be ready to give assistance to your neighbors if they need help. But whatever you are doing, listen for the warning signals of approaching fallout. If you have been in the open after an attack, when you get indoors, take off your outer clothing and leave it outside the fallout room. Have a wash if possible. By these precautions, you will get rid of any fallout that may have settled on you. Once this has been done, go to your fallout room and stay there. It is vital that you should know what to do immediately after an attack. On your actions may depend the safety of your home, your family, your neighbor, and yourself. Any delay on your part may endanger the lives of everyone living around you. Once the black warning is sounded, it means your home is in a fallout area, and you must remain in your fallout room. Remember, you may have to remain under cover for at least a week, and our general guide to the days you will have to spend in your fallout room.
Stay in your refuge room.
During this period, listen for announcements and instructions on your radio. It will be all right for you to leave the fallout room to collect more food or water, or to go to the lavatory. But time spent outside your fallout room should be kept to the absolute minimum. Except for these reasons, you should never go outside the fallout room. Fallout dust cannot usually be seen. Only the wardens and the police, with their special instruments, will know the level of fallout radiation. The amount of fallout will vary from place to place. It will be heaviest in the middle of the fallout area and grow less and less towards the edge of the food. Where fallout is particularly heavy, people may have to be moved to a safer area. If this does become necessary, you will be told by radio or by the warden or the police. Keep your suitcase to hand and be ready to move, but on no account leave home before you are told. If you have to be moved, put on some warm clothes and take with you enough food to last for 24 hours. This food should be packed in airtight containers. Private car owners will be asked and expected to fill every available seat. As few people as possible will be moved, and for most of you, it will be stay in your fallout room. Use your food and water carefully, and always remember the danger of radiation. For your own safety, you should wear plastic or rubber gloves. Keep all your food covered. If the cover is unbroken, then the food will be safe. Before you open the food, wipe the packing carefully. This will prevent any fallout dust that has settled on the package from getting into the food. When you've unwrapped the food, you should immediately dispose of the wrapping in the dustbin. Your water must also be kept covered. Do not use any mains water for cooking or drinking until you have been told that it is safe. In the meantime, use your water sparingly and reuse the water for different purposes. Always remember, boiling contaminated water will not make it safe for drinking. Everywhere, the dangers from fallout will decrease as time passes. When the danger from fallout is lessened sufficiently, the civil defense or the police will tell you when you can go outside. Do not go out until you are told it is safe. And even then, you may only be able to go out for a very short time. Essential work will be restarted as soon as possible. Emergency arrangements may be made for the distribution of water. You will be told when it is safe to stay out for longer periods, but there will still be danger from fallout, and nobody should remain outside for longer than necessary. You must still be careful not to bring fallout into the house from outside. Wear some stout boots or shoes to go out, and change before returning indoors. Wash the boots thoroughly when you get back. Wipe down all the working surfaces in your kitchen, your larder, and also anything that may come into contact with food. You should wear plastic or rubber gloves, and when you have finished, you should wash the gloves. Burn all your rubbish. Although the fire will not get rid of radioactivity, it will reduce the bulk of your rubbish and help to prevent the spread of ordinary disease. If the present world situation does lead to a nuclear attack on this country, it is vital that you shall have taken the necessary measures to safeguard your home as much as possible. It is vital that you should know what action to take in the event of a nuclear attack. If you fail in this, your negligence could endanger the lives of your friends and neighbors as well as your own family. Remember that the civil defense wardens and the police are here to aid and advise you. But wherever you live, you must know how to help yourself and be prepared to help others if their lives are in danger.
Nuclear explosions are caused by weapons such as H-bombs or atom bombs. They are like ordinary explosions, only many times more powerful. They cause great heat and blast. They also make a cloud of deadly dust which falls slowly to the ground. This is what is called fallout. So these are the two dangers. First, heat and blast, which is followed by fallout. The heat and blast is so severe that it can kill and can destroy buildings for up to 5 miles from the explosion. Fallout is dust that is sucked up from the ground by the explosion. It can be deadly dangerous. It rises high in the air and can be carried by winds for hundreds of miles before falling to the ground. You can protect yourself and your family, and later on we will show you what steps to take. These are the warning sounds you must recognize. First, the attack. If an attack is suspected, the sirens will sound a rising and falling note like this. When fallout is expected, you will hear 3 bangs in short succession. They will be sounded by means of maroons like this. Or you may hear 3 gongs like this. Or 3 whistles like this. These all mean that fallout is expected. Warnings of the attack and of fallout will also be broadcast. When the immediate danger of air attack or fallout is passed, the siren will sound a steady note like this. are the warning sounds again. Attack. Fallout. Here is a reminder of what the air attack warning sounds like. This is the sound. When you hear the attack warning, you and your family must take cover at once. Do not stay out of doors. If you are caught in the open, lie down. And now here is a reminder about fallout warnings. When fallout is expected, you will hear 3 bangs in short succession, like this. In some areas, the warning may be given by means of 3 gongs, like this. Or you may hear 3 whistles, like this. All these 3 types of sounds indicate that fallout is expected. When you hear them, you must stay in the safest position in the house. Keep the door shut. Do not go outside the house until you are told it is safe. Here is the all clear warning. When you hear this sound, you can leave your cover. But keep listening for further warnings. You must now choose a room in your home which will give the best protection from fallout. If you live in a house, the safest place is the ground floor or basement. Choose a room with the smallest amount of outside wall. The farther you are from outside walls in the room, the better the protection. If you live in a block of flats, which is more than 5 floors high, it is important not to use the top 2 floors. The safest places are inside passages away from outside walls and windows. If the block is 4 floors or less, the best place for a fallout room is the basement or ground floor. If you live too high up to be safe, you must make arrangements now with your neighbours in the lower floors, or make some suitable arrangements to shelter with someone close by. If you live in a one-story house, like a bungalow or B-flat, the building itself will not give you much protection. So the best thing is to make arrangements now to shelter with someone close by. If this is not possible, look for a space in your home which is farthest from the roof and the outside walls. Later, we shall be telling you how to strengthen and improve your fallout room. We have told you how to choose a fallout room in your home. The best place is farthest away from the roof and outside walls. Your fallout room will protect you, but you will make it even safer by strengthening a small part. This part will be your inner refuge during the worst winter. Making a refuge is not difficult. The main things you will need are shovels, boxes, cartons or large plastic bags, earth or sand. Start collecting them now. These things may also come in handy. Saw, screwdriver, nails, screws, string or thin rope, scissors or pencil. One idea is to make a lean-to of wood, resting against an inside wall. Strong boards or doors taken from their hinges are quite good. Stop them slipping down the wall by fixing them to the floor with a strip of wood. Then cover the wood with bags or boxes filled with some heavy material, like sand, earth, books, or rolled up clothes. Don't forget to fix the bags and boxes so that they don't slip on. Across the 2 open ends of your refuge, you should make thick walls of bags and boxes of earth or sand, or heavy furniture, packed tightly with heavy material. Don't forget to leave an easy way into and out of your refuge. Next, a cupboard under the stairs. That is another good place for a refuge. Put boxes of earth or sand on the stairs and along the walls of the cupboard, like this. If the stairs are on an outside wall, make the wall thicker with bags of earth or sand. Stack the bags up to a height of about 6 feet. Here is another idea. Use tables if they are strong and large enough for you and your family to shelter beneath. Make solid sides around the tables out of heavy furniture, boxes filled with sand, earth or books. If you can, lay strong boards or doors across the top and cover them with bags of heavy material. This will make a good roof over your refuge. If you live in a caravan or other building of lightweight construction, which provides you with very little protection against falling, your local authority will be able to advise you on what to do. Whatever type of refuge you have, the main thing to remember is that the more heavy material you have around you, like earth or sand, the more chance there is of safety. Start looking now for materials for your fallout room and inner refuge. Here is a list of things and some ideas to use. Bricks, concrete blocks, bags or boxes filled with earth or sand. If you cannot get hold of sandbags or boxes, try travel bags, haversacks, suitcases, pillowcases, or anything which will hold sand or earth. Strong pieces of wood, heavy furniture, doors taken off their hinges. All these things can give you good protection. Think about it and make plans now. Decide what you already have in your home that will be suitable for making a refuge. Decide what you may need to bring into the house: earth, bricks, sand, etc., to strengthen it. Decide where you will store all these materials, so that you will know exactly where they are when you need them. You can use these materials like this for thickening the floor above your fallout room, for building your inner refuge, for blocking windows, doors, halls or passages, for thickening outside walls. All these materials can save your life. Gathered your materials for an inner refuge. The time has now come to make everything ready for you and your family in case an air attack happens. This does not mean that war is bound to come, but there is a risk of this, and we must all be prepared. So don't waste time. Start now. To help you, we will remind you once again about choosing a fallout room and an inner refuge. First, choosing a fallout room. That should be a room in your house which will give you the best possible protection from falling. A room that is farthest from the outside walls in the room, or one with the smallest amount of outside wall is safest. Whatever room you choose, remember that the further you can get away from radioactive dust in or around your home, the safer you will be. So in a house, the safest place is the ground floor or basement. In a block of flats, do not shelter in the top 2 floors if the block is 5 floors high or more. Go to the lower floors, ground floor or basement. The central corridors will give good protection. If you live in a bungalow or similar one-story home, it will not give you much protection. If you cannot make alternative arrangements, choose the safest place, which is a space farthest from the roof and outside walls. And now a reminder about your inner refuge. We have told you that your fallout room should be the safest place in your home. Even this is sometimes not safe enough, however, particularly for the first 2 days and nights after an attack, when the danger from radiation could be critical. So you need, inside your fallout room, an inner refuge, a fortified area to give you greater protection during the worst of the attack. The inner refuge should be thickly lined with dense materials to resist radiation, away from outside walls if possible. Now for its construction. Make a lean-to with wood, resting against an inside wall. Use boards or doors taken from their hinges. Stop them slipping down the wall by nailing a strip of wood to the floor like this. Cover them with dense material and fix some rope around it so that it won't slip. Partly close the open ends, leaving an easy way in and out of your refuge like this. Another good place for a refuge is a cover under the stairs. Reinforce the stairs and the side like this. If the stairs are on an outside wall, stack up containers of earth or sand to make the wall thicker to resist radiation. If you've got tables large enough to give you and your family sufficient shelter, use them. Make the sides solid with heavy furniture or boxes of books or sand. Reinforce the top with strong boards or doors and cover them with dense materials. More details are given in the booklet, Protect and Survive. If you haven't got one yet, get one from the post office now. And start right away making your home and your family as safe as possible from nuclear attack. Start now in your fallout room and in a refuge. Thicken the floor above your fallout room. Start blocking windows, doors, walls, passages. Thicken the outside wall of your fallout room. Fallout dust gives off dangerous radiation. It cannot be seen or felt. It has no smell. Anybody staying within reach of fallout for too long can fall ill or die. So you must keep away from fallout until it is safe. This may mean staying in your fallout room for up to 14 days. Prepare yourself for this now by storing all the things you need. Put them in your fallout room or stacked up within easy reach close by. Here is a list of the most important things you will need. Drinking water. Food, mostly in tins. Portable radio and spare batteries. Tin opener, bottle opener, some cutlery and crockery. Warm coat. And now here is a list of some things which will make living in your fallout room much more comfortable. Bedding, sleeping bags, portable stove and fuel, saucepans for boiling water and cooking, torches with spare bulbs and batteries, candles, matches, table and chairs, toilet articles, soap, toilet rolls, change of clothing, first aid kit, household medicines and prescribed medicines, box of dry sand, cloths or tissues for wiping plates and utensils, notebook and pencil for messages, brushes, shovel and cleaning materials, rubber or plastic gloves. Toys for children, books and magazines to pass the time. Clock and calendar. Finally, don't forget your booklet, Protect and Survive. It tells you how to make your home and family as safe as possible. All the items we've just told you about are listed in it. may come quite unexpected. We will now tell you what to do if a warning sounds when you are at home, and then we will explain what to do if you are out of doors. First, if you are at home. If attack is imminent, you will hear the attack sound like this. So take cover at once. Send your young children to the fallout room, then go quickly and turn off the gas and the electricity at the mains. Close down stoves. Damp down fires. Shut windows. And draw curtains. Then go to your fallout room and stay there. If the fallout warning sounds are heard, they will be like these. You should now move yourself and your family to the safest area in your fallout. That is, you should get inside your inner refuge and stay there. After 2 days, the danger from fallout will get less, but don't take any risks by contact with it. The longer you stay in your refuge, the better it will be for you. Listen to your radio. Stay where you are and keep listening to your radio. Now, this is what you should do if you are out of doors when the warning sounds. Take cover at once when you hear the attack sound. If you cannot reach home in 10 minutes, take cover in the nearest building. If there is no building nearby, try to find some solid cover. If there is no solid cover, lie flat in a ditch or a hole and cover your head, face and hands as fast as you can with some of your clothes. If you hear the fallout warning, seek the nearest and best cover as quickly as you can. But before entering the building or cover, brush or shake off any fallout dust you may have picked up and get rid of it. Change your outer clothing if you can. Stay under cover. When the all clear sounds, like this, it means that you are safe from attack or fallout for the time being, and that you can go out again. But keep listening for further warnings, or to your radio for further advice. After an attack, you may have to stay in your home for about 14 days. So make sure to store plenty of water and food for your family. Water is more essential to life than food. You can live for a long time with a little food if you have enough water or liquids to drink. How much is enough? Well, each person should drink about 2 pints a day. So, for 14 days, 3.5 gallons is enough for one person. but you should double this amount if you can. Then there will be some to spare for washing your face and hands. Keep drinking water in your fallout room. Store it in plastic containers with a screw top, or in bottles or jars covered to keep out dirt. Store the rest in kettles and saucepans and in basins in the bathtub. Try to keep some tins of fruit juice as well. Now, food. Stock enough for everybody for 14 days. You may not be able to cook anything hot, so buy foods you can eat cold and that will not go bad. Buy food well wrapped or in tins. By the way, don't forget your tin opener and bottle. You will do best to buy lots of different kinds of foods if you can, so that you won't get bored with too much of the same thing. Stock up with meats, vegetables, fruit, tinned or powdered milk, and special foods for babies or infants. You will also need some sweet things, like sugar or jam, and biscuits. Keep the food in a cool, dry place until you have to take it to your fallout room. Foods that will go bad quickly should be the first to be eaten. Try to ration everything so that it will last up. A nuclear explosion produces intense heat. This can get through unprotected windows and set fire to things in your home. But there are steps you can take now to cut down the risk. First, whiten your windows with white paint to reflect some of the heat wet. This will cut down the risk of these fires. Then get rid of junk lying about in your attics and upper floors, especially old papers and magazines, which can catch fire easily. The heat from the bomb strikes at attics and upper floors most easily, and fires there are usually the hardest to cover, so pay particular attention to these places. In other parts of the building, clear away papers and magazines. Then net curtains from windows. And any old rubbish inside or outside your home which is likely to catch fire easily. Small fires can be put out easily if they are tackled at once. If they are left, they spread fast and soon get out of control. The fire brigade may not be able to reach you, and you will have to protect yourself without any help. So prepare none. If you have a fire extinguisher, keep it handy. Or a garden hose would be very useful. Keep buckets of sand and water ready on each floor. When you take cover in your inner refuge, you must not go outside until it is absolutely safe. And if the fallout is heavy, you may be in your refuge for quite a long time. Although the danger from fallout will get less and less as time goes by, you will never be able to judge for yourself how bad it is. Advice will be given to you on the radio, so keep listening. This advice over the radio and other instructions and news will be very important to you while you're cut off from the people living around. So make sure your radio is in good working order. And if you have a spare radio, keep it in your fallout room. Radios must be battery operated because your electricity may be cut off. so be sure to get some spare batteries. After a fallout warning, you have been advised to take cover in your inner refuge. The first 2 days will be the most dangerous period because fallout will be at its worst. So it is in your best interest to stay in your inner refuge the whole of that time, however cramped or uncomfortable it may be. But if you must leave the refuge to go to the lavatory or to get more water or food, don't stay out a second longer than is necessary. In any case, don't go outside the fallout room at all. After 2 days, the danger from fallout will be less, but it may still kill you. So the longer you stay in your inner refuge, the better your chances are. Although it may be fairly safe for you to move about inside your fallout room, it certainly will not be safe for you to go outside the house until the radio tells you. So keep listening to your radio for advice. At first, you'll be told when you can go outside the house for a short time to get rid of lavatory waste and rubbish. Then, as the danger from fallout begins to pass away, you will be able to stay out for longer spells. There may still be a lot of fallout dust lying about, so be careful not to bring it back with you into the house. Keep a separate pair of boots or strong shoes for going out. Before coming in, take them off and wash or wipe them, soles as well. It is also a good idea to wear rubber gloves while you are outside. Try to keep the younger people indoors as much as possible. In fact, it will be far wiser for only people over 30 to work outside until things get better. And now a reminder of some of the things we have told you in earlier films. Fallout can kill, though you cannot see it, feel it, or smell it. There is danger outside, so don't go outside. Stay in your fallout room until you are told it is safe to come out. After an attack, fires will start in many places. The fire brigade may not be able to help everyone, so it might be up to us to tackle the fires in our own homes. Here is some advice on how to do it. Make sure that you have turned off gas and electricity at the mains. Don't smoke. Then start checking for fires. Start at the top of the house. Check roof space and every room, putting out fires before they get out of control. Small fires can be put out quite easily if they're tackled at once. If they are left, they spread quickly and take hold. Use water from the tap, the risen. Earth and sand are also useful. Put all the members of your family to work putting out fires in the house. When you are satisfied that the inside is safe, check the outside of the house and make sure that you are safe from any fires which have started nearby. When you have seen to your own household, help any neighbor in need. If you have used any of your precious drinking water to fight fires, make good your reserves. Fill up all your containers again and put covers on. Turn off your water supply at the mains. It may become contaminated. If your house is damaged, you may have a little time before a fallout warning to carry out minor jobs to keep the weather out. Curtains or sheets may be used to cover broken windows or holes. Then listen for the fallout warning. If it comes, take cover in your inner refuge and stay there. Earlier we told you what to do to prepare emergency lavatory arrangements in or near your fort. It will not be easy for you to keep clean in shelter conditions, mainly because it is unlikely that there will be any water to spare for washing or for flushing the lavatory. But cleanliness is essential to prevent sickness. Here are a few simple rules to help you. All toilet containers should be covered when they're not in use. Pour in some disinfectant. It will cut down the smells and keep off flies. When you have used the bucket lavatory, wipe your hands with toilet paper soaked in a little mild disinfectant. Throw the paper into the container and put the lid on. Keep an eye on small children and see that they do the same as you to keep clean. Don't let the bucket get too full. If you have lined it with a plastic bag, tie the neck tight before lifting it up. And put it in a separate dustbin well away from the floor. Put a fresh plastic bag into the bucket with a few drops of disinfectant. Cover the bucket with a lid. When it is safe to do so, take the dustbin and its contents outside the house. Remove the waste and bring the empty bin back. Food scraps, empty tins and other rubbish should be wrapped up tightly in newspapers and put in a separate dustbin. Keep the lid on. If you have got only one dustbin, use that for toilet waste only. Put all other rubbish separate in plastic bags or paper until you can take it outside the house. Keep your hands as clean as possible. Wear rubber gloves for dirty work. Try to avoid touching food with your hands as much as possible. Keep your knives and forks, plates and cups, etc. clean. Dry, clean sand is quite good for this. After an air attack, your water taps may run dry, or the water in them may be too dangerous to drink because it has been poisoned by fallout. So your life may depend entirely on what you have stored. Keep it clean by covering the containers. Its main use is for drinking, but use it sparingly. For each person, you should have stored at least 2 pints for each day. Don't waste water on washing or anything else. If you must use water for cooking, use as little as possible. If you heat cans of food in a saucepan of water, don't throw the water away. It can be used over and over again. By the way, make sure you pierce the top of the can before heating. Dip your dirty knives and forks into the pan while the water is still hot. Water is life. Save it. You should by now have built up an emergency reserve of tinned food or other foods that don't go off quickly and that can be eaten cold. Keep your food reserves in your fallout room. And remember to keep them well covered to protect them from fallout dust. There might be fallout dust on the packaging. Take care this does not get into the food. So wipe the tins, packets and bottles. You may not be able to replace your stocks of food for a long time, so make them last. Most of the time, you'll be resting in your fallout room, and you won't need to consume much food. Eat the smallest amount you can get by, and plan meals carefully so that there is no waste. And remember, keep your food covered from fallout. Wrap open tins and loose foods. Prepare small amounts at a time. You may not be able to replace your stocks for a long time, so ration food carefully. After an attack is over and the all clear has been signed, arrangements will be made as soon as possible to treat any people who are ill or ill. Listen to your radio. Details will be given about what to do, when to do it, and how. If anyone dies while you are kept in your fallout room, move the body to another room in the house. Label the body with name and address, and cover it as tightly as possible in polythene, paper, sheets or blankets. Tie a second card to the cover. The radio will advise you what to do about taking the body away from the bed. If, however, you have had a body in the house for more than 5 days, and if it is safe to go outside, then you should bury the body for the time being in a trench or cover it with earth and mark the spot of the burial.
With this decay rate in mind, consider radioactive fallout conditions likely upon us after a massive attack. Within an hour, fallout will be a serious problem in the vicinity of explosions which occur on or near the ground. By 7 hours after the attack, the fallout area covers more and more of the country as the prevailing winds expand the fallout in the downwind pattern. 24 hours. 48 hours. Without shelter, until a few days later,
would melt until it would reach safety in the ocean. Then the fallout particles would be brushed off and out of the food. If fallout settles on your food, the food itself is not harmed. Its radiation damages only living tissue. And you would easily decontaminate it. Almost the same as the food in everyday food preparation. Actually, even if you accidentally swallowed some fallout particles, it wouldn't federal government has a nationwide fallout shelter program. The goal is adequate fallout shelter space for every man, woman, and child. And this goal can be reached. For with knowledge of radiation, we can face the facts about fallout. Take action to protect ourselves. And learn how to live.
remember that life in a shelter will not be like living under normal conditions. Suppose, in our story, there had been no shelter, no food, no organization, no training. Suppose no one was there who understood the nature of the purpose of the shelter occupancy. Suppose no one had known when or if ever there would be hope of returning to the life previously lived. In the perilous world of which we live, shelter is required. Community shelter planning will resolve the destiny of our children. Should the sirens would nurse you into believing that the kind of shelter better prepared, or would you not be prepared? Shelter living will be what you living is what you have provided. As our normal, everyday way of life may not be suspended, this is our wish and our hope. But how white? Working man, daily. In our own interest, all of us should have some idea of what to expect. Our survival should ever depend on living.
Long before man appeared on Earth, the world and life on it were changing, ever changing. In the face of changing nature, all living creatures must evolve, adapt, and struggle to survive. Man, too, must survive. Man also progresses, but along the way, times result in dangerous changes in our environment. Unchecked, these changes may threaten our very survival. Man must stop the mishandling of nature and work toward a future with clean air to breathe, clean water to drink, uncontaminated soil in which to grow the food he needs. Oxygen producers like these, vital to our environment, must be protected. This is our deep commitment to the future. How we science of the peaceful uses of atomic energy is one of the ways man is responding to the fight to preserve and restore his environment. The Atomic Energy Commission, from its inception, has had a vigorous program in environmental research. The application of atomic energy to meet environmental objectives moves in two directions. First, supplementing the conventional power plants that pollute the atmosphere with clean atomic power stations. Secondly, use the atom as a research tool to study our environment, especially the burdens placed on the environment by modern industry. This challenging work offers many exciting career possibilities for scientists and technicians. Power production is one example. Electric power requirements in this country are doubling about every 10 years. Sometimes the heavy demand exceeds the supply, causing power blackouts
discharge of noxious chemicals into the atmosphere is one thing coal and oil-burning power plants have in common. Atomic power plants, on the other hand, don't release smoke containing such contaminants that pollute the atmosphere. Both conventional and atomic power plants discharge some excess heat into adjacent waterways. These thermal effects must be controlled and minimized. Methods are being developed, such as giant cooling towers and man-made lakes. Whatever the source, water is converted into steam, turns the turbines, which drive the generator. When the steam leaves the turbine, it must be cooled and condensed back to water, returned to the boiler. The cooling water does not make contact with the radioactive core. Cool water is usually taken from rivers, lakes, or the ocean. At atomic power plants, the water is pumped through the condenser, returned to its source as warmer water. Although so far, no significant detrimental effects of warm water on fish and other aquatic life have been found in the vicinity of nuclear power plants. Thorough investigation will continue in order to assure that environmental impact will not be excessive when weighed against man's growing need for electricity. But of course, slightly warmer water may be used beneficially for agriculture and even recreational purposes. Future, more efficient nuclear generating stations, such as the breeder, will release less heat per kilowatt. However, nuclear power plants do release very minute quantities of radioactivity from cooling water and into the atmosphere. But federal standards carefully and conservatively regulate such releases to protect the public. In actual practice, the amount of radioactivity released is held to only a very tiny percentage of the amount permitted by the standards. The natural background radiation you would receive from taking a plane ride across the country or from spending a summer in the mountains would be about the same as you would receive if you lived next door to an atomic power plant for an entire year. One of the reasons for the success of our agriculture was the use of insecticides, resulting in more abundant crops due to the elimination of pests. But unfortunately, insecticides can be harmful to livestock and wildlife. However, insect control is a necessity. So, by using atomic energy as a research tool, experiments are underway at a number of universities to develop insecticides to do their job without causing side effects that harm the food chain, plant, animal, and man. At the University of California at Riverside, the Department of Entomology is doing decisive research work in this area under the guidance of scientists such as Dr. Roy Maputo. The purpose of these scientists is to aid in the development of insecticides which are selectively active. To put it simply, the goal is the creation of insecticides that control pests but do not harm humans or livestock. Well, how does nuclear energy come into the picture? Radioactive carbon is the research tool that traces the effectiveness of the insecticide being tested. Two samples of insecticides are being tested. Sample A, used as a control, is a compound currently on the market. It is poisonous to warm-blooded animals. The new compound B is selectively toxic to insects, and therefore may be used without harmful effects to our environment. Both samples were previously tagged with radioactive carbon. inside a metabolism chamber. The second mouse is given a sample of compound B, the new insecticide. The mouse is put into another metabolism chamber. Test animals spend predetermined time periods in the metabolism chambers. At certain intervals, urine specimens of the two test animals are taken to determine the relative metabolizing action of samples A and B by the test animals. Specimens are placed into this radiation gun to measure the radioactivity. Now a tiny amount of both samples is placed on this chromatography plate. The compounds will move to different places on this plate. The position will indicate the nature of the compound. The slight radioactivity of the compound makes it possible to trace them on photographic film for easy visibility. Thus, atomic energy, with the position of the spots, helps the chemist reach the conclusion that compound B, the new insecticide, is indeed less dangerous to warm-blooded animals than the sample taken from the new insecticide. Although it is illegal to dump oil into coastal waters, some ships still flush out their fuel tanks, discharging oil into coastal regions, usually at night. As a result, oil slicks may be washed up on beaches, destroy marine life, and even cause fire. Since our bodies of water are already burdened with more waste material than they can manage, the Coast Guard has added another duty to its patrol: protection of the marine environment. When an oil slick is located by the helicopter, a Coast Guard cutter is dispatched to take samples. Scientists using atomic techniques will be able to relate the sample to the moving ship. Samples for comparison can be taken from ships suspected of dumping the oil in that area. The link between the oil slick and the suspected ship can be established by a novel use of atomic energy called neutron activation analysis. It produces atomic tests of the samples under investigation. A small nuclear reactor is used for this. The oil samples scooped from the ocean, as well as the samples collected from suspect ships, are made radioactive. Then, a radiation gun is used to produce a profile of each radioactive sample. The information is also recorded on a printout. The atomic fingerprints are compared. In the event that an oil sample from the suspected ship matches one of the oil samples retrieved from the ocean, the authorities can be reasonably sure who caused the pollution, and existing laws can be enforced. Wave energy, strong ocean currents, often cause beaches and sandbars to appear and disappear. Beach erosion is a constant threat to recreation areas and homes near the sea, and sand eventually clogs channels. In some cases, constant placed along the beach according to a predetermined pattern. These experiments are conducted at Point Cool, California. Deposits are made also below the waterline. Frogmen place stationary radiation monitors to help measure the radioactively tagged grains of sand that are spreading along the ocean floor. This roller-shaped apparatus, called the ball, is a highly sensitive outdoor radiation tower. It is used to survey the gold-tagged sand. The study of one series of placements may continue for a week until decay and dilution make radiation undetected. The ball is pulled along the beach through the water, distances up to 1,500 feet from the shoreline. The signal picked up by this atomic radiation detector accurately reproduced data as indicated by this map, showing for the first time the movement of the sand under the sea. Rivers, by their very nature, have their own cleaning mechanism. But ever-increasing amounts of waste dumped into rivers often exceed the flowing water's capability for self-purification. With the use of AEC-produced radioisotopes, the Georgia Institute of Technology is studying the problem. These men are preparing atomic tracers for use in this research work. Bottles containing the atomic tracers, red dye, are emptied into flowing water. The red dye is used so that the movement of the radioactivity can be easily followed. Samples collected at various points downstream will be taken to the Institute for analysis. The tests will indicate the decrease of radioactivity of the atom. These data relate to the amount of oxygen absorbed from the air and will give a much more precise picture of a flowing stream's ability to purify itself. That is, to absorb oxygen, upon which the very life of a river depends. The findings will aid in the proper placement of sewage plants, industrial facilities along rivers, and help determine permissible waste output. Industrial waste are killing fish in the Great Lakes. In order to fight the problem, scientists are determining which pollutants are mainly responsible. They collect fish throughout the Great Lakes. The case history of every fish is fed into a computer. Then the vital organs of the fish are removed for analysis. AEC's Argonne National Laboratory, in cooperation with the U.S. Bureau of Fisheries, is trying to isolate the fish killers. Neutron activation analysis is used to identify poisonous elements such as mercury, copper, zinc, and arsenic, shown here in their specific profiles, their telltale atomic fingerprints. This information helps to provide a picture of the dispersion and types of the pollution in the Great Lakes. Belching batteries of smokestacks used to be the hallmark of industrial success. Today, they are signposts of deep concern to ecologists and the medical profession. AEC's Brookhaven National Laboratory, in conjunction with the National Air Pollution Control Office, took off on an airborne program of diagnostic studies to determine the extent and composition of typical plumes and their effect on the surrounding areas. Industrial plumes contain polluting sulfur dioxide. In this compound are naturally varying amounts of two types of sulfur. The ratios of the two types of sulfur can be measured by means of stable atomic isotopes. This information helps determine the intensity and dispersion of corrosive smoke particles and predict guidance of Dr. David Gates, using radioactive tracers to study the way plants convert carbon dioxide into oxygen, and to what extent plants can absorb substances such as sulfur dioxide, one of the most dangerous pollutants from coal-burning furnaces and automobiles. Photosynthesis is a key link in the chain of life. Functioning green leaf and other green plants is responsible for the survival of the human race. Changes in the environment due to pollution could jeopardize the process of photosynthesis. So it is essential to investigate the effect of pollution on the plant life of the world. Studies conducted here for the health of the animal yield valuable answers. Other answers will come from experiments in this forest at ABC's Oak Ridge National Laboratory under actual outdoor conditions. The tagging capability of radioactive cesium is used to learn more about the growing process of plants and trees, help determine the flow of elements through the forest and its grasses, shrubs, and trees. And now, take a look into the possible future of the atom's fight to help our environment. Perhaps underground atomic explosions could provide safe storage space for waste materials. New types of power plants employing nuclear fusion, producing temperatures hotter than the sun, and hopefully someday supply almost limitless pollution-free energy for the world of tomorrow. And perhaps the same energy in the form of the fusion torch could reduce the vast amounts of industrial and household wastes to their original elements, making the continued recycling of our resources a possibility. Yes, the fight for the preservation of the Earth's environment goes on. And one very valuable weapon in the arsenal for the ecologist is magic of the atom.
Would be our air bases. With all our aircraft on the ground, our weapons of interception or retaliation not instantly available, we might face another and infinitely more costly Pearl Harbor. Disaster, some of our aircraft must always be in the sky or on the alert, carrying nuclear weapons. These weapons are always unarmed. They will be armed only following a decision by the President of the United States. Only these ready aircraft with nuclear weapons can form our first-line deterrent force in peacetime, our sure striking force in case of attack. We, the American people, understand and accept this necessity for our survival. But we want to know the facts about one question. the facts, the United States Air Force presents This bomber carries a nuclear weapon. It is a well-designed, carefully maintained, skillfully flown airplane. But airplanes, just like it, have crashed and burned. There was no nuclear explosion, no radioactive fallout. These are the facts. The bombardier watches over controls as safe as human ingenuity can make them to prevent accidental bomb release. But nuclear weapons have been dropped inadvertently. There was no nuclear explosion, no radioactive fallout. These are the facts. And specially instrumented aircraft verify these facts in a continuing nuclear safety program that tests our nuclear weapons under controlled conditions that simulate every conceivable hazard. Vital to this nuclear safety program is Air Force Special Weapons Center at Albuquerque, New Mexico. Here, in ultra-modern laboratory buildings, work scientists in and out of uniform. They work with the incredibly complex equations of nuclear physics, which derive from Einstein's famous relationship of mass to energy. These cryptic figures, programmed into lightning-fast computers, are the theoretical base upon which these scientists, together with those of the Atomic Energy Commission, can build nuclear weapon safety. By research, design development, and laboratory test, they ensure weapons not yet built against accidental nuclear explosion. They have been doing this successfully since 1945 in safety conferences with other Defense Department agencies and the Atomic Energy Commission. In 13 years, there have been a few accidents, but not one has resulted in nuclear explosion or radioactive fallout. These are the facts. What keeps our nuclear weapons safe? To understand why there has never been an accidental nuclear explosion, you must first know how these explosions can be produced, the general principles of nuclear explosions. Any explosion is the result of a very rapid release of a great amount of energy. Conventional explosions result from the rearrangement of four atoms in some explosive material. For example, in TNT, the rearrangement of four atoms of hydrogen, carbon, nitrogen, and oxygen produces explosive force. On the other hand, nuclear explosions result from rearrangement within each atom. This may be a joining together or fusion, as in an H-bomb, or the splitting apart or fission, as in an A-bomb. At present, an H-bomb explosion starts with fission. So the splitting of the nucleus of the atom is the basic principle of nuclear weapons. All matter is composed of one or more of the 100 odd elements. Of these, the atoms of the metals uranium and plutonium can be most readily fissioned to cause nuclear explosion. These elements are mildly radioactive. They emit short-range, low-penetration alpha particles while in their unfissioned state. These alpha particles do not have the harmful effects of the longer range and stronger gamma rays, which are given off by certain elements such as radium or by the products of nuclear fission. The atoms of uranium and plutonium are among the heaviest. Heavy because the nucleus of each atom contains large numbers of fundamental particles called protons and neutrons.
neutrons which may go on to split other nuclei. The resulting fission products become highly radioactive, emitting the long-range and dangerous gamma rays. The split nucleus weighs less than the whole, and this difference in weight is released in the form of energy, nuclear energy. After fission, harmful gamma radiation. Before fission, innocuous alpha radiation. To build up a nuclear energy release, the fissionable material must be of a certain size, shape, or density. Then one of the neutrons escaping from a split atomic nucleus will, in turn, split another, and a chain reaction is set up. The mass is now releasing nuclear energy, but not quickly enough to cause a nuclear explosion. This condition is called critical. If the mass is now suddenly increased, so that more neutrons are trapped each time an atomic nucleus is split, a multiplying chain reaction is maintained. Now the mass is supercritical, causing a nuclear explosion. Density of the fissionable material can be as important as mass in building up a nuclear explosion. The same sphere can be compressed so that the atoms are closer together and neutrons split more atomic nuclei, making the smaller mass critical. If compressed still more, a multiplying chain reaction sets in, causing the mass to become supercritical in a nuclear explosion. Nuclear weapons make use of both of these principles. A gun-type device can increase the mass of fissionable material to a supercritical state instantaneously. One subcritical mass is propelled forcibly into another by an ordinary power charge. The increased mass becomes supercritical. A multiplying chain reaction builds up until the nuclear explosion. Obviously, if any mechanical device keeps these two subcritical masses apart, the weapon is nuclear safe. Applications of this fact prevent accidental nuclear explosions in gun-type weapons. Another kind of nuclear weapon is the implosion type. It compresses the fissionable material to greater density to make it supercritical. To do this, the sphere is enclosed by a shell of ordinary explosive designed to direct its explosive force inward. This effect is called implosion. The detonators attached to the explosive are connected to a complex firing device, which can fire every detonator simultaneously. When all the explosive is detonated simultaneously, the nuclear material is compressed into a supercritical mass, which results in a nuclear explosion. Implosion-type weapons are nuclear safe because only the specially designed firing device can produce the simultaneous detonation of all the ordinary explosive, a deliberate effect possible only by the precise firing mechanism. Should a single detonator be fired accidentally, whether by malfunction, crash impact, or fire, the explosive would not provide the all-around compression necessary for implosion. Instead, it might push the nuclear material out of the shell, break it into small pieces, or even burn it. This unfissioned material emits only alpha particles because no nuclear explosion has taken place. These alpha particles do not penetrate the skin. The simplest precautions can prevent their intake into the body, and the simplest cleanup measures can remove them. So you see, each type of nuclear weapon has its own safeguards against accidental nuclear explosion. These are the facts, and they are based upon practice as well as theory. Specially instrumented aircraft fly the tests that verify what happens inside a weapon, what accident hazards the nuclear components may have to withstand. Nuclear safety is everybody's business. Although Air Force flies the test missions,
material is not wasted. They supplement the detonation tests that have been made with the complete nuclear weapons. Impact or shock does not cause nuclear explosion or radioactive fallout. What has exploded is the ordinary explosive, which is an essential part of nuclear weapons. The ordinary explosive in a nuclear weapon can be a hazard, exactly as in a conventional bomb. Depending upon the amount and location of the explosive, and the speed and height of the drop, we may experience a variety of ordinary explosions. Large ones, small ones, or none at all from impact of the bomb. Beside the hazard of impact, frequent tests are run on the hazard of fire. To learn what temperatures and pressures would be created inside a weapon by an aircraft fire, various types of bombs are subjected to a flame bath of burning fuel. Because fire would also destroy the precious nuclear material, it is replaced by instruments. Their readings are compared with known characteristics of the fissionable material to assure that temperatures higher than any aircraft fire will not set off a nuclear explosion. The characteristic white flame indicates that the ordinary explosive is burning in the weapon. Sometimes the explosive detonates because of close confinement and intense heat. The effects of such explosion are measured and compared with those in an actual nuclear weapon. Fire and ordinary explosives do not create the conditions necessary for nuclear explosion. These are the facts. And on the vast desert ranges of the Atomic Energy Commission, the facts are verified by safety testing live prototypes of all new weapons before they go into production for our stockpile. The tests are costly in money and manpower, even more costly in the fissionable materials on which our nuclear strength depends. But they do provide insurance against nuclear accidents, which make them a bargain at any price. Some take place deep in the earth. Fantastically complex instruments replace the five senses. They record what happens when some of the explosive that surrounds the nuclear material of a new weapon is deliberately detonated. They record only an ordinary explosive blast. A random detonation has not created the implosion which would compress the nuclear material to a supercritical mass. There was no nuclear explosion, no radioactive fallout. Each new design must be proved nuclear safe, able to withstand accident, fire, or random explosive. Other tests with nuclear weapons are made above ground. These are also designed to test the nuclear safety of new weapon types by intentionally detonating the explosive which surrounds the fissionable material. Sometimes these tests also provide data on the side effects to be expected if the fissionable material is broken up by the explosion. Air samplers and test pads are used to gauge the area, intensity, and duration of these side effects. In this way, they learn not only what does not happen when a charge is deliberately fired, but what does. The explosive does break up the nuclear material and scatter parts of it over a small area. This fissionable material is mildly radioactive. chroniclers or alpha counters have determined that no injurious concentration exists. The alpha particles emitted do not penetrate skin or clothing, so this material is harmless when on the ground. Only simple cleanup measures are necessary, plus an effort to find and save the valuable material. The findings from all tests set up to measure possible radiological hazard are no external radioactive hazard from material on the ground, slight radioactive hazard from prolonged inhalation of material suspended in a small area near the accident, but none from the short exposures necessary for firefighting, rescue, or cleanup of the small area involved. These are the facts. Facts that have dispelled the fearsome myths about accidents involving nuclear weapons. For anyone near an accident, whether or not the crashed airplane carries a nuclear weapon, here are the safe and simple rules. Stay away from the crash unless you are needed for rescue. Bystanders endanger themselves and hamper others. To be safe, keep at least a quarter of a mile away from any burning airplane. At this distance, you are safe from the flames, which may explode the jet fuel, from detonating explosives, and from flying debris. These are the real dangers in rescue or firefighting, as they have always been. The trained men who bear these responsibilities know how to do their job and get quickly away from all these hazards. After the emergency is over, the area is monitored for radioactive material and, if necessary, cleaned up by specially trained teams. Other specialists care for burned or undetonated pieces of ordinary explosive. Until this is done, access to any crashed area is controlled to prevent accidents and speed up the work. The tests you have seen have proved the safety of our nuclear weapons program over and over again. But the grim reality is the payoff. How safe is a nuclear bomber coming in for a crash landing?
have come to expect. These safety measures are essential. Today, however, we are threatened with a new form and magnitude of disaster. For this is the age of the atom. So long as we are confronted with this unprecedented threat, protection of our children must be a basic goal of every educational program. We can achieve this goal only by undertaking a comprehensive civil defense program in all of our schools. Protection from nuclear attack is possible. Local conditions will dictate the courses of action. There is a general concept for every school system to follow in developing a civil defense program. First of all, the general objectives and main features of the plan must be carefully worked out by the superintendent for presentation to the school board.
We presented this program to you a week ago at your meeting, and I need hardly tell you that this proposal to expand our school protection program was worked out with the close cooperation of Mr. Miller, our city civil defense director. The program consists of two main parts: protection to take care of our immediate survival needs, and a curriculum program to include civil defense in our courses of study. Before I describe in detail,
In this meeting, the school superintendent is seeking the board's approval of the general proposal. Before he can proceed with a more detailed plan, the board must endorse the proposal and authorize funds for development and implementation of the plan.
Thank you, Mr. Douglas. The board has already studied the outline of this proposal that you gave us last week. Those in favor of proceeding with a more detailed plan? Opposed? Carried. And now I think we should
A few days later, the superintendent meets with his staff and all principals to explain the new directive and to make specific assignments for detailed planning. The curriculum coordinator heads the curriculum committee. The safety supervisor is appointed chairman of the protection committee. The school architect engineer is made chairman of the fallout shelter committee. Many others, such as the chief school nurse and the head building custodian, are assigned responsible positions. Everyone on the staff has an important role. The civil defense director is present to explain how the schools fit into the total community survival plan. Principals are charged with full responsibility for developing and executing both the protection and curriculum programs in their own schools. Programs which will conform with those established for the entire system. Before calling a meeting of the entire staff, principals in turn discuss the program with some of their key people. The school's safety supervisor is appointed as the civil defense coordinator. And teachers serving on the curriculum committee are told to prepare for special meetings to find ways of building civil defense into the courses of study. One of the first steps in developing the protection program is to decide on the best and most economical ways of providing shelter from radioactive fallout. With the aid of the local civil defense director, school superintendent and his architect engineer make detailed plans for including dual dual-purpose fallout shelters in all new school construction. Plans are approved, funds obligated, and the real work gets underway. When this shelter is completed, it will also serve as the school cafeteria. Existing school buildings throughout the system are surveyed to determine what areas within them are best adapted for shelter use or for ready conversion to shelters. This area, for instance, was formerly used for coal storage, but now it serves as both fallout shelter and workroom for school theatrical productions. This school needed more classroom space, but to add it above ground would have taken away valuable playground area. The problem was solved by building dual-purpose sheltered classrooms underground, according to specifications furnished by the Office of Civil and Defense Mobilization. Alternate plans for evacuating the schools in target areas are also developed. If there is enough advance warning of an attack, civil defense plans in many target cities call for sending children home from school. Some target cities, such as this one, if there is adequate warning time, plan a general evacuation to safer areas. With the help of the local civil defense director, the school superintendent makes certain that arrangements for evacuating schools in his system are coordinated with those already established for the community at large. Cooperative arrangements must also be made between school and local government officials at reception areas. Development of an adequate internal warning system for the schools also is carefully worked out to supplement existing civil defense warning facilities. This community has a good outdoor warning system with sirens covering the entire area. Everyone here knows that the alert signal, a steady blast of from 3 to 5 minutes duration, means to take action as directed by the local government. And that the take cover signal, a wailing tone or a series of short blasts of 3 minutes duration, signifying attack is imminent, means to take cover at once in the best available shelter. To supplement these outdoor signals, an indoor warning system is needed. Although there are other approved systems for instantaneous relay of warning, bell and lights are used here to alert the school. Public address systems are installed so that emergency instructions can be given to the students and staff in the shortest possible time. Here's how the whole system works. When a warning is received by the local government through the attack warning system, sirens and bell and lights throughout the community are activated simultaneously. Every school in the system receives this signal. On receipt of the warning, the switchboard operator immediately informs the principal. Using the public address system, he gives appropriate directions to his staff and to the students. It cannot be stressed too strongly that any civil defense warning signal used in schools must be clearly distinguishable from other types of alarms. overemphasized. Through the calm efficiency of their teachers, youngsters gain confidence in arrangements made for their security. While individual schools may have different requirements, all must hold periodic drills to assure immediate response to warning signals. An adequate school fallout shelter should contain enough provisions to sustain students and staff for at least 2 weeks. In this combination shelter cafeteria, the cafeteria manager is in charge of emergency feeding facilities. It must be stocked with blankets for everyone assigned to the shelter. If the school is dependent on a vulnerable community water system, a special well may have to be provided for emergency water supply. Battery-powered radios with Conelrad frequencies 640 and 1240 clearly marked on the dials must be available to receive emergency information. A telephone tied in with the city's Civil Defense Control Center. First aid and medical supplies. Sanitation facilities and means for safe disposal of rubbish and wastes. Radiological monitoring equipment. An emergency electric power generator. And adequate ventilation are among the special items which must be provided. Because children would need some form of recreation, an area within the shelter should be available for physical activities and play. Of course, if time would permit, they would be in their own shelters at home. While the protection program is taking shape, civil defense is introduced into the curriculum at all levels. This third grade class, for example, visits emergency facilities in the community, like the local fire station. Here they learn that the people who protect them every day are a vital part of civil defense. In this 5th grade class, children make posters on home preparedness. Gradually, an awareness develops that civil defense is as natural, as meaningful, and necessary as everyday safety rules. The conditions of survival are learned. Preparedness becomes a personal responsibility. Discussion of the effects of natural disasters leads to a realistic grasp of the consequences of a nuclear war. The objective of curriculum planning is to give each student a background in the needs and methods of civil defense so that he will be prepared for living in the nuclear age. Under the supervision of the school nurse, first aid courses are taught as a regular part of the physical education program. real relationship between good food and good morale. Civil defense concepts should evolve naturally from existing subject matter, as in this 12th grade class in American government.
And if we were ever attacked, we would need more than ever the help and leadership of our government. Most states and many localities have already adopted this program to help us recover and to preserve our constitutional government. The first point in this continuity of government program is to establish automatic lines of succession for important positions. In a serious disaster, many officials may be unable.
This is a sound peculiar to our time. A sound that is meaningful to this 12th grade physics class studying the effects of radioactive fallout. These radiological defense instrument kits for use in science classes have been distributed to high schools throughout the nation by the Office of Civil and Defense Mobilization. From experiences like this, young people grow in their understanding of the problems they must face, of the responsibilities they must accept as citizens of the nuclear age. If it is to be a successful program in our schools, civil defense must also be understood and practiced in our homes.
Vitally important area. We've been talking about some of the precautions schools are taking to protect their children and to help them meet the challenge of our time. But I want to stress that it's just as important that we carry this knowledge and these preparations into the home. Let's take a look at some of the things that we as parents and as citizens are obligated to know. Warning signals, what they mean. Your community plan for emergency action. Protection from radioactive fallout through shelter. First aid and home emergency preparedness. Use of Conrad 640 or 1240 on your AM radio for official direction. These are some of the things that we must do. Prepare a family fallout shelter and equip it with 2 weeks' supply of food and water. First aid kit, a battery-operated radio. Since we are in a target area, prepare an evacuation kit for your automobile. Include a supply of food and water, a first aid kit, a battery radio, and blankets. First, let's talk about the family fallout shelter. This is a model of one of the types of family shelters recommended by the Office of Civil and Defense Mobilization. It is best to
The protection of our families at home and in schools is basic to the success of any community or national survival program. For the sake of clarity, let's review some of the steps in preparing a school civil defense program. After outlining a general plan with the help of the local civil defense authority, the superintendent makes his proposal to the school board. With the board's approval, he calls a meeting of his staff and principals to explain the new policy. Starting with the emergency plan, a shelter program is developed under the supervision of the architect-engineer who works with the civil defense director. If evacuation is called for in the community survival plan, school procedures are designed to conform. The entire school system is provided with a reliable warning system. Individual schools carry out their directives and refine their programs through regular drills and exercises. techniques into the existing courses of study. And home preparedness is stressed as a necessary extension of the school survival program. Approaches to the development of school civil defense programs will necessarily vary according to local conditions. But if these guidelines are followed, while working closely with local civil defense officials, schools will be better prepared to meet any disaster. A nuclear war may never come, especially if we are prepared. But we cannot ignore the threat. The stakes are too high.
Over 19,000 disasters strike somewhere in our country every year. That's more than 50 disasters every day. Some are major, like Hurricane Camille. I witnessed this awesome destruction. But Hurricane Camille, and even the greatest natural disaster we could imagine, would be dwarfed by the loss of lives and property in a nuclear attack. I'm saying this because I have good reason to be concerned. My name is John Davis, and I am the National Director of Civil Defense in Washington, D.C. Our purpose in civil defense is to protect you and to help you protect yourself in time of emergency. That's the reason we have prepared this special film to tell you what actions you should take to help protect yourself and your family in case of a nuclear attack. The protective actions you take today will not be wasted if a nuclear attack is not occurring. Experience tells us that these actions save many lives in natural disasters and other emergencies. The surest way to fight disaster is to do nothing to avoid it. Give this film your hope.
Most likely, the most important fact in the world today is this. We've been living in the atomic age for a long time. And none of these catastrophes are really predicted. So honestly, fear has something to happen. True, there have been dangerous moments like the Berlin and Cuban crises. But so far, sanity has prevailed. And hopefully it always will. And yet there's no point in looking away from reality. We live in a troubled and uncertain world. And it's have to go on being troubled for a long time to come. The nuclear gene is out of the bottle. And until the world finds a way to clap it back in, and then put a lock on the socket, there'll always remain the outside chance that what our nation and a great many others have been working so hard to avoid could conceivably happen to all. And of course, so long as even the slightest possibility exists, it's something we must question, guard against, prepare for, just as a common sense precaution. So let's talk a little about these things, about what's being done to protect you, and about what you can do to protect yourself in time of emergency. Of course, our first and strongest line of defense lies in what the strategists call the power of deterrence. In our intercontinental missiles, our nuclear submarine systems, strategic air command, in the ability of all our military forces to retaliate even after a surprise attack, and do it with such enormous force that the aggressor would be defeated, most likely destroyed. And in that fact, that knowledge alone lies the strongest incentive any enemy could have to avoid launching a nuclear war. But behind the sword, there's also a shield. Very quietly, but steadily over the years, we've been building a nationwide system of civil defense designed to save lives, to protect as many of our people as possible. It consists of many things. The National Warning System, tied in with NORAD, the North American Air Defense Command, able to alert the whole nation in a matter of minutes. A monitoring network with more than 65,000 locations to measure and report fallout radiation. And most important, a very large and growing public shelter system to protect us from that radiation. Local governments have been making detailed plans to deal with all kinds of disasters. An emergency broadcast system organized to keep you informed. And thousands of special emergency control centers to direct life-saving and recovery. In short, if attacks ever threaten, there'd be help available from many sources. You would not be alone. But a life, inevitably, would depend on you. There's no point in denying or trying to minimize the grim fact that a nuclear attack would take a heavy toll of lives. But in all the Defense Department studies, and there have been many of them, two things come clear. Even under heavy attacks, our nation could, in fact, would survive. And our losses would be much less. Your own chances of survival much greater if each of us would take time to do just three things. First, understand the dangers we face. Second, make some fairly simple preparations to meet them. And third, learn exactly what to do if emergency comes. Then do it. 1, 2, 3. Now, about those dangers. There are some you can't do much about, but others you can. And knowing the distinction between the two could very well mean the difference between staying alive or dying an utterly useless death. When a thermonuclear weapon explodes, four things happen. First, a brilliant white flash of flame. Then, a searing wave of heat shooting out from the nuclear fireball. The blast wave hurling debris before it. But, even under heavy enemy attack, only 4 or 5% of our land, 1/20th of the country, would be affected at all by blast and heat. All the rest, and all the tens of millions of people in it, would escape untouched. Except by radioactive fallout. It could spread on the winds to cover not just 5%, but 80 or 90% of our country. But that's one danger you can do something about, if you know a few facts about fallout. When a nuclear weapon explodes anywhere near the ground, tons of dirt and debris are pulverized into millions of tiny particles, swept up into the fireball, turned dangerously radioactive. They drift downwind in the mushroom cloud, then start slowly falling back to Earth. The heaviest and most dangerous particles first, after 15 to 30 minutes in the area nearest the explosion. The lighter ones later, perhaps hours or days later, and hundreds of miles away, wherever the winds may take them. But wherever they fall, in fields and streams, on rooftops, or in the streets, they spell danger. Each one of these fallout particles, no larger than grains of salt or fine sand, is like a tiny X-ray machine, shooting out deadly, invisible gamma rays that can damage or destroy the cells of your body. Too large a dose in too short a time means sickness or death. But it's a useless protocol. Useless because it's unnecessary. If you use the three defenses you have against it. One is time. The most dangerous period would be the first 24 hours after fallout arrives. But fortunately, radiation decays very rapidly. It's like an elevator going down fast. For example, if all the fallout were down on the ground 1 hour after the burst, then by 7 hours, the radiation would have dropped to just 10% of that 1 hour level. By the end of 2 days, it would be down to 1%. And in 2 weeks, it would be just 1/10 of 1%. In short, with shelter, you can wait it out. But while you're waiting, you'll need protection. And that comes from two things: mass and distance. Mass meaning thick, heavy, dense material. Concrete. Steel. Even ordinary earth to absorb or deflect those deadly gamma rays. Reduce the amount of radiation reaching. And distance, because the farther you are from the source of the radiation, fallout particles settled on the roof or on the ground outside, the safer you'll be. Put those two together, mass and distance, and you've got a fallout shelter. You'll find it wherever you see this sign. The black and yellow sign that marks our community fallout shelters. And they could mean the difference between life and death in time of emergency. Of course, if you're convinced of the utility of it all, and you want to just stand out there and bear your breast of radiation, that happens to be your privilege. But if we all found out of the Cuban crisis, that kind of talk becomes just talk. As the real danger mounted, so did our will for survival. We all discovered a reason for living. Ourselves, our family, our children, and we were all looking for that. Well, it's there now, ready for use. A nationwide system of more than 100,000 large public fallout shelters located in office buildings, apartments, schools, factories, stores. And it's a good idea to look around, to know at all times where the nearest ones are, just in case they ever prove useless. Of course, there's still not enough, and they're not everywhere. Usually, there's plenty of fallout shelter downtown where most people work, but less in the suburbs where a lot of us live, and not nearly enough out in the country where there aren't enough buildings or heavy construction. If that's the problem, if you're just too far away from the nearest community shelter to reach it in time, then you'd better do something. One answer may lie in your own home. If the house has a basement, earth and concrete may give you some shielding already built in. And to help fill in the gaps, the Office of Civil Defense has been conducting home surveys in many of our states, asking each homeowner to fill out a questionnaire, then telling them by means of computers exactly how much fallout protection is already there. If you've already taken part in one of these surveys, you already know that your house has none. And if it hasn't, well, usually all it takes to improve, to build a home shelter in your basement, is some do-it-yourself effort, plus a couple of $100 at most for concrete blocks and other materials. And in extreme emergency, if crisis seems imminent and no shelters available, it's still possible to improvise some last-minute protection against fallout. Not as good as you find in a regular shelter, but any protection's better than none, and it could be enough to save your life. Remember, use mass and distance to reduce radiation. Choose the corner of your basement that's most below ground level. Set up a sturdy table or workbench there. Wall it in with the heaviest materials you can find. Bookcases, chests of drawers, appliances, trunks. Then, fill the drawers with earth or sand to give added protection. Cover the top with as much heavy shielding as it will hold. House doors, bricks, flagstones, firewood. Then, once your family is all inside, block up the entrance, leaving an opening at the top just large enough to let air in, of course. If you live in the country and your home lacks a basement, a storm cellar outside can serve just as well. If the existing roof is made of light wood, put in extra posts and braces to support the added weight. Then cover the roof with a foot or more of earth to give you solid protection. After everyone's inside, use bricks, sandbags, or heavy concrete blocks to wall up the entrance, leaving just a few inches open at the top, again for ventilation. Or you can improvise a shelter in your yard. Dig an L-shaped trench, 4 feet deep and 3 feet wide. Make the longer side of the L big enough to accommodate your family. The other leg will serve as an entranceway and help reduce the amount of radiation getting into the shelter area. Shore up the sides of the trench for safety. Then cover it with house doors and heavy timbers. Then pile on a foot of earth for protection. As a last resort, even if there's no basement or storm cellar available, you could get some limited fallout protection by improvising a shelter on the ground floor of your home. Use a hallway, an inner room, or large clothesline, away from outside walls and windows, with doors, chests, trunks, and boxes filled with earth or sand. You can create an enclosure large enough to live in for the short time of that first peak period of danger. If the inner space you've chosen is too small to allow room inside for all these shielded materials, place them against the other side of the wall, in the surrounding room. All these are last-minute measures, of course, for use only in extreme emergency if you just can't reach a regular fallout shelter. But it's better not to wait that long to make some preparation, particularly when it comes to supplies. Most community shelters, though not all of them yet, have been stocked with a basic requirement: emergency food rations, water containers, sanitation equipment, medical kits, radiation detection equipment. But even so, in a time of crisis, shelter living would be Spartan, none of the comforts at home. And there are things you'd better plan to take along to help ease that shelter strain. A battery-powered radio, flashlight and extra batteries, a blanket for each member of the family, any dietetic foods or special medicines your family may need for reasons of health, like insulin, heart tablets, antihistamines. If you have a baby, don't forget bottles, disposable diapers, cans of formula, and special baby foods. And of course, if your neighborhood shelter is not stocked with the basic supplies, you'll need to take as much water and ready-to-eat food as you can carry. That's true of a family home shelter, too, for here you'd be on your own. So keep a 2-week reserve of supplies around the house for use in emergency. For shelter use, canned goods are best. Soups, canned meats, all the pre-cooked foods. And packaged goods like crackers and wafers that don't need refrigeration. And water. That's even more important, so you can't live without it. As a minimum, 3 or 4 gallons for each member of your family, and store it in tightly capped bottles or plastic containers. If the supply runs low, don't overlook all the alternate sources right inside your house. The canned fruit and vegetable juices on the kitchen shelf. Soft drinks, milk, and ice cubes from the refrigerator. The 20 to 60 gallons in your hot water tank. And of course, all the water trapped in the pipes of your house plumbing system. In case of attack, simply turn off the main water valve in your basement to avoid having it all drain away if there's a break in the outside mains. Then, turn on the faucet located at the highest point in your house, probably the upstairs bathroom, to let air into the system. Then, draw the water as you need it from the faucet located at the lowest point. It'll be pure, drinkable, and free from fallout. If some fallout particles are on food that you brought in from the outside, don't worry. They can't make it radioactive. Simply remove the particles, and you remove the danger. Just wash or peel the fruits and vegetables. Wipe off the packages or cans. For safety, it's better to make sure that babies or small children aren't allowed food or liquids that might be contaminated. However, in extreme emergency, thirsty people should not be denied water, even if it contains fallout. There's little danger that any adult could swallow enough to hurt him. It'd be like trying to swallow sand. Of course, we've only skimmed the surface here of things you need to know and do. But you'll find everything covered in fullest detail in this Citizen's Handbook prepared by the Office of Civil Defense. It's titled, In Time of Emergency. It deals with natural disasters as well as the dangers of enemy nuclear attack. And you can get a copy from the Civil Defense Office of your own local government. Read it. Study it. And above all, keep this quick checklist of emergency actions in mind. First, know your local emergency action plan. Hundreds of cities and counties have prepared and printed specific community shelter plans, complete with maps and detailed instructions, telling every resident where to go for the best available protection against fallout. Make sure your family knows the plan, where the nearest shelters are, and how to get there in time. Second, keep a stock of emergency supplies on hand. Foods that require no cooking, enough drinking water and other liquids, special medicines, radio, flashlight, blankets. And if you're planning to use a home shelter, don't overlook the problem of sanitation. Lay in a metal container with a tight-fitting lid, some plastic liners, and household disinfectants. You'll need them for disposal of waste and prevention of disease, to keep your family healthy through a shelter stay. If attack seems imminent, take precautions against fire. Close doors, windows, Venetian blinds. If you don't have Venetian blinds, cover the windows with household cleaning towels, aluminum foil, whitewash. For even in the fringe areas, miles away from any nuclear explosion, the heat waves could ignite trash and dry wood, set fire to your home. Have some basic firefighting tools on hand, especially a good fire extinguisher, and keep your garden hose connected. Unless your local authorities advise otherwise, fill the bathtub and other containers with water. For under enemy attack, the fire department may not be available. You'll have to help yourself. Above all, make sure you know what your local attack warning system is. There are a few exceptions because of special local conditions, but in most communities, the standard attack warning is this. A wavering, undulating sound on the outdoor sirens lasting 3 to 5 minutes. Or a series of short blasts on whistles and horns. And when you hear that sound, believe it, an actual enemy attack has been detected. Don't reach for the phone to find out what's happened. The lines need to be kept clear for official emergencies. And you need to find shelter promptly. If you're caught in the open, if there's a sudden flash and you feel warmed at the same time, don't look at the flash. Move. Take cover behind a tree, or a wall, in a ditch, or a covert. Curl up on the ground and cover your head with hands and arms. Stay there till heat and blast waves have passed. Then get to shelter before the fallout starts falling. Then turn on the radio. The emergency broadcast station serving your area will be bringing you news, presidential messages, civil defense instructions. You will not be alone. In many shelters, you'd find friends and neighbors who have been specially trained in shelter management, radiological monitoring, medical self-help. All across the country, the Civil Defense Monitoring Network would be measuring and reporting fallout conditions. And from the state and community emergency control centers, your own local authorities would be directing life-saving and recovery operations, keeping in close touch with each shelter. Just follow their official instructions and stay in the shelter till they tell you it's safe. All these things are easy to reach and fairly simple things to do. None of them cost time or effort or money. If nothing ever happens, if the world maintains its sanity and enemy attack never comes, that time and effort will still have been well spent. For the better, both we and the nation are prepared, the less chance, really, that anything will happen. And if they ever prove needed, they could save your life in time of emergency.
Medical self-help is an emergency measure to be used only in cases of sudden or extraordinary misfortune. If people require medical care in the course of normal, everyday living, they should always be treated by a doctor. However, when disaster strikes, you may not be able to obtain trained medical aid in time. There are many forms of disaster. They can happen to you and your family at any moment. This film is one of a series on medical self-help. Its purpose is to teach you what to do in an emergency situation when there is no doctor.
This powerful X-ray machine, a tool of medical science, is being used for healing purposes. The radiant energy it emits is able to kill all living tissue within its being, both sick and healthy cells of the human body. Its invisible rays so highly penetrative that protective shielding with lead glass windows must be used. X-rays are much like the gamma rays of radioactive fallout. We began our picture with X-rays because you are all to some degree familiar with their effects. But radioactive fallout is another matter. If you're like most people, it creates many questions in your mind, and you have doubtless read or heard some falsehoods and misconceptions. This film will tell you what you need to know about fallout, so that if our country is ever subjected to a nuclear attack, you can help yourself and your family to survive its dangers. For fallout is probably the most dangerous product of nuclear disaster in terms of the number of people who could be affected. It is also the one from which we are best able to protect ourselves. Let's examine what happens when a nuclear weapon is exploded near the Earth. First, there is blast, or the pressure wave created by the explosion, along with heat, the most intense ever created on Earth. Both will extend great distances from the point of the explosion, from 1 to 20 or 25 miles, depending on the size of the weapon. However, the further away you are from the site of the explosion, the less are the chances you will suffer the fatal effects of blast and heat. There is yet a third immediate result of a nuclear detonation: initial radiation. The final effect is residual radiation, the main concern of this film, or radiation that follows the explosion and one that may remain at high altitude for some time before falling back to Earth. What exactly is residual radiation? Our sun, like other stellar bodies of the universe, is a giant nuclear furnace, burning at temperatures of millions of degrees, while emitting various types of radiation. Among these are gamma rays, shorter in wavelength than their closest neighbor, X-rays. The Earth's atmosphere prevents these radiations, dangerous to the health of man and animal, from reaching our planet. However, when a nuclear weapon is exploded, man is creating on Earth, in the splitting of atomic nuclei, his own nuclear furnace to produce the gamma and beta radiations of outer space. Let's see now just how this radiation is created. At the time of the burst, vast amounts of dirt, stone, and other debris, vaporized by the heat of the explosion, are sucked up into the rising clouds. As the mushroom cloud forms, these particles are made radioactive, or as they cool and condense, they are contaminated by residue from the bomb. These particles, when they fall back to Earth, are what we call radioactive fallout. Can you or anyone else predict with accuracy the pattern by which fallout particles will return to Earth? The answer is no, for fallout will depend on the number, size, and location of nuclear weapons exploded and the direction of upper air currents. Let's, for example, explore the fallout produced by one of these nuclear weapons. It sends its column of radioactive material up to 80,000 feet, or about 16 miles or more above the Earth. Here, the radioactive particles, beginning to drift downward, are at the mercy of upper air currents that vary from day to day. Descending at various altitudes through many different layers of air that may be moving at varying speeds and directions. Thus, winds on the surface of the Earth give little help in determining the direction or the occurrence of fallout. Meteorologists, with their special instruments, however, can appraise altitudes as well as the total distance fallout will be carried. A nuclear attack, keep tuned to your local radio station. It will keep you posted where fallout is taking place and its approximate amount. Though you may be able to see this dust once it reaches the Earth, you cannot see or detect the radiation it emits without the aid of radiological instruments. Nor can you taste, smell, or feel this radiation. Why is fallout so dangerous to human and animal life? Because each particle gives off radiation as if it were a tiny X-ray machine. This radiation consists mainly of gamma rays, which are extremely penetrating. Like X-rays, gamma rays are able to injure, even destroy the cells of our body if we are exposed to a sufficient dosage long enough, or if we eat or drink material contaminated by fallout particles. Exposure to gamma rays can make you sick, can even cause death. However, no matter how long one may be exposed to fallout, he does not become radioactive, nor can anyone catch radiation sickness from him like a contagious disease. In fact, this radiation cannot make anyone or anything radioactive. Now let us suppose that fallout has descended on this can. We'll let salt represent fallout dust. The particles don't go through the tin. The radiation does, but radiation is harmless to all except living material. It has no effect on the food inside. Now, if you wipe away the fallout particles, or better still, wash them away, the food inside cannot be contaminated and is perfectly safe to eat. The same is true of all foods and liquids that have been protected by packaging or containers, even the thinnest layer of cellophane. If you don't swallow the dust,
There is no ill effect. If water for washing is in short supply, canned goods that may have been exposed to fallout can be handled safely with a piece of paper towel. Use one sheet of paper to lift the can and turn it upside down. There is no dust on the bottom. Now dispose of the paper. Wipe the sides of the can with a new piece of towel. And don't forget to put the contaminated paper in a covered receptacle. Now open the clean top. There will be no harmful particles in the food itself. A sealed loaf of bread that has been exposed to fallout can be salvaged in a similar manner. Turn the loaf upside down to expose the bottom, which will be clear of dust. Then dispose of the towel. Now insert a sharp knife through the wax paper at the center of the loaf and cut upward, making a slot 4 or 5 inches lengthwise. Insert your fingers through the slot and rip the paper slowly open. The bread can be safely removed to a clean plate. Finally, dispose of the wax paper. Contaminated vegetables, such as potatoes, can be pared like this. Use a clean piece of newspaper and, working first in one corner, cut off one end. Move to a clean surface of the paper and peel in this manner. Move to another area of the paper and remove the other end. Dispose of all peelings and soiled paper carefully. After handling any contaminated food containers or vegetables, wash your hands. Fallout dust is dangerous, but it can be dealt with by following safe procedures. There is another widespread legend, the fear that fallout spells death to all life on Earth. The plain fact is that even if a great number of nuclear weapons were exploded, the resulting fallout would cover only a small area of the world's total land mass. The real concern then is this: if we are in that area, how do we protect ourselves? Like X-rays, radiation from fallout can go through almost every kind of building material. Over 99% would pass through glass, 66% through wood sheathing, 50% through a brick veneer wall. But only 1% of gamma radiation would penetrate 18 inches of concrete. And though it's not a building material, it's important to know that only 1% would pass through 25 inches of earth. Quite aside from the shielding effect of building materials, the intensity of radiation decreases with the square of the distance from the source. Thus, 10 feet away from a particle of fallout, the radiation rate is only 1% of that encountered at a distance of 1 foot. Other things being equal, the central parts of a building are safer. The radiation rate, or the intensity from fallout, decreases with the passage of time. In fact, for every 7-fold increase in time, the radiation will be reduced by a factor of 10. That means that at 7 hours after the explosion, the radiation level will be about 10% of its intensity at 1 hour. At 49 hours, it will be about 1%. Within 2 weeks, the radiation rate can be expected to decay to about 0.1%. Therefore, the most vital period to seek protection from fallout is the first few days after nuclear attack. Even more so, the first few hours. But remember, even with the passage of time, a low level of radiation can be dangerous. That is why you may need to remain within a sheltered area for as long as 2 weeks. These then are the three basic factors in protection against fallout: time, distance, and shielding. Time, meaning the longer you stay protected from fallout, the safer you will be. Distance, or the further away you get from fallout, the safer you will be. Shielding, meaning the more mass or weight you put between yourself and fallout, the safer you will be. You have often seen this sign on buildings. It means that indoors is a public fallout shelter, one of many and various kinds of buildings in your community that are similarly identified. Architects and engineers have carefully surveyed the shielding qualities of these areas to ensure they offer a minimum protection factor of 40 or more, meaning that in the event of fallout from a nuclear explosion, the mass and weight this shelter will place between you and the source of radiation will make you at least 40 times safer than if you were outdoors. Each of these shelters will hold at least 50 people and has been stocked by the government with austere supplies: food, water, sanitation equipment, medical kits, and radiological instruments. But what about millions who live in suburbs or rural areas, often far beyond quick walking distance of the nearest public shelter? With foresight, you can have a home shelter for the protection of your family, built from specifications and cost estimates for various types of shelters provided by your local civil defense office. The home shelter should be stocked with supplies of food and water sufficient for 2 weeks. Here you are afforded time, distance, and shielding if and when fallout, so dangerous to human health, should ever occur in your community. Just how much radiation can you receive without becoming sick? We measure exposure to gamma radiation from fallout in units called Roentgen. They're the same units used to measure X-rays, named for Wilhelm Conrad Roentgen, the discoverer of X-rays. People and animals may develop radiation sickness if they have been exposed to large amounts of radiation over a short period of time. Few people become sick who have been exposed to a total radiation dose of 100 Roentgens or less. However, exposure to more than 300 Roentgens over a period of a few days will cause sickness, may cause death. And if you receive an exposure of 600 Roentgens in that same period of time, death is almost certain. How can you tell just how much radiation you've been exposed to? These are the instruments commonly used to detect and measure radiation. They are part of the equipment supplied to the radiological monitoring team of every public shelter. With them, you can determine not only the total amounts of radiation received, but also the dose rate per unit of time, or the dose rate in Roentgen per hour. This is the dosimeter, conveniently shaped to be worn on one's person at all times. It is able to measure the total accumulated radiation exposure in Roentgen. The charger adjusts the dosimeter to a zero reading prior to its use, with each separate exposure to radiation building cumulatively on the dosimeter gauge so that a reading of the total dose is available at any given time.
Geiger counter. This instrument measures radiation in fractions of roentgens per hour within or outside the shelter. Finally, the survey meter, able to measure higher intensities of radiation that may exist outside the shelter. For home shelters, detection and measuring instruments are available from commercial sources. However, most householders will rely chiefly on their portable radios to receive readings as they are taken by civil defense monitoring teams. If there is a nuclear attack, and you survive the initial effects of an explosion, you will have at least a half hour to get to a public or home fallout shelter. Therefore, to be safe from radiation sickness, get into the best available shelter as soon as possible. Once there, stay put, because each time you're exposed to fallout radiation over a period of a few days, the dosage continues to build until it reaches dangerous quantities. If you're among those compelled to travel through a fallout area on essential errands, there are certain rules to follow. Protect your body with boots or rubbers, gloves, headgear, and outer clothing that can be removed before you re-enter the shelter. On returning, brush off the rest of your clothing thoroughly, as well as any parts of your body that may have been exposed to fallout. If sufficient water is available, wash your face and hands carefully. Remember, these are the dosages of radiation as they affect human health. 100 roentgens, little or no effect. 300 roentgens, sickness or death. 600 roentgens, death. Recovery from radiation sickness is nothing new. Patients who are treated by X-rays routinely experience this sickness and get over it. Of course, the dosages they receive are carefully measured. Just as in combating the virus of the common cold, your general state of health will often govern how quickly you can throw off the effects of mild or moderate radiation sickness. In an emergency situation where there is no doctor, always treat radiation sickness by treating its symptoms. In fact, these symptoms are often similar to those produced by extreme anxiety or emotional stress. So it's best not to try to determine their cause. I repeat, do not try to diagnose. Merely treat the symptoms, just as you would if they were the result of any other type of illness. These are the symptoms of mild as well as moderate radiation sickness, one or more of which may appear shortly after exposure to fallout. Fatigue, loss of appetite, nausea, vomiting, prostration. The treatment is rest. For nausea, you may give the patient any of the commercial preparations that settle an upset stomach, or 1/2 teaspoon of baking soda in a cup of water. Tea and other hot liquids may be helpful. When a high fever is present, apply cold wet pack. Aspirin also tends to reduce the fever. In severe radiation sickness, along with the early symptoms, other symptoms may appear a week or more after exposure. Recovery is possible, but it'll take longer. The symptoms are diarrhea, inflammation of mouth and throat, loss of hair. For treatment, control the diarrhea and give aspirin and warm water gargles. People are naturally alarmed at the thought of bodily changes that may follow severe radiation sickness, such as loss of hair or sterility. These conditions are usually temporary and will disappear with recovery. So I hope we've dispelled another commonly held myth. You can get over radiation sickness just as you get over many others. Nevertheless,
don't minimize the danger of fallout. Remember, its effects are cumulative. The only real protection against it is to take shelter. Now, let's review some of the outstanding facts we have learned in this brief exploration of a vitally important subject. Fallout is composed of trillions of particles of dust that are made radioactive by residues from the nuclear weapon during the aftermath of the explosion. In a nuclear attack, depend on your local radio station to tell you where fallout is taking place. You may be able to see some of the fallout dust when it reaches the earth, but you cannot taste, smell, or feel the radiation itself. The gamma rays given off by fallout are able to injure or destroy the living cells of our body if we are exposed long enough. Food or water in containers that prevent contamination by fallout dust is perfectly safe. Radiation is harmful only to living tissues. Packaged foods that have been exposed to fallout should be opened carefully. By following proper procedures, you can eat such foods without danger to health. Radiation can pass through most building materials, but its intensity is diminished in proportion to the weight and mass of the material or the shielding. The intensity also decreases with distance from the fallout. The radiation rate will decrease or decay rapidly with time. It is most dangerous in the first few days after explosion. Thus, the three basic factors that protect you from fallout radiation are time, distance, and shielding. You should know the location of the nearest public shelter in your community. Inside it, you will be at least 40 times safer from fallout than you would be outdoors. And it has been stocked with supplies to sustain its occupants for up to 2 weeks. If you're not within walking distance of a public shelter, you can provide a satisfactory home shelter for your family. Radiation is invisible, but we have accurate instruments with which to measure it in Roentgen units. The dosimeter can be worn on the person and measures the accumulated radiation exposure, the total dose at any given time. The Geiger counter measures radiation in fractions of Roentgens per hour, inside or outside the shelter. The survey meter is used to measure the higher intensities of radiation that may be present outside the shelter. Assuming that you have the protection of a good shelter within a half hour after nuclear attack, you will probably have little or no radiation sickness. If there are victims who appear to have radiation sickness, do not diagnose. Treat the symptoms. Perhaps the most important thing you have learned is to see the danger in its true perspective. Make no mistake, nuclear attack would be a terrible catastrophe. Millions of our people would be killed by the initial blast and heat. Millions more would be threatened by death from radioactive fallout. But that is a threat that can be combated. Can, with knowledge, preparation, and courage, be faced and conquered.
food. Be prepared to take along food, water, the other necessities we mentioned. If you decide to take shelter at home, know how to improvise and improve your protection there. And do lay in enough supplies. Relocation. If you live in a high-risk area, your local authorities may ask you to move to safety in a small town or rural area. Be sure you follow the plan so you'll know exactly where to go and what to do. Whatever the choice, take time now to make your own family protection plan. Know what you need. Make your plan practical. And make sure each member of the family knows exactly what to do if crisis ever comes. Don't wait till you need it. That's too late. Do it now.
The Earth from space can seem a fair and pleasant place. And perhaps through strength and unceasing efforts of settling international disputes by peaceful means, we'll manage to keep it that way. The greatest danger is hopelessness. The fear that nuclear attack would mean the end of our world. So why not just give up, lie down, and die? That idea could bring senseless and useless death to many. For protection is possible. And your own chances of survival will be much greater if you remember these facts about protection in the nuclear age.
tools in the hands of skilled craftsmen have helped to build the world we know today. A world of towering steel, of giant airplanes, fast-moving transportation, a world of mechanical wonders, products of fine craftsmanship whose origin lies in the proper use of simple hand tools. But to more fully appreciate these tools and their part in our world today, let's turn back the pages of history. 60 or 70,000 years ago, long before the beginning of civilization, our primitive ancestors lived in caves, and we today might also be living in caves, except for a certain event that took place within the gloomy depths of this long-forgotten cavern. Here, a certain Stone Age craftsman by the name of Primitive Pete stumbled upon a very good idea. He suddenly realized that by fastening a stick to a rock, like this, he could extend the length of his arm, like this, and thereby greatly increase the force of his blow, like this. Thus was born the world's first practical hand. Oh, did we say practical? Well, anyway, it was a good idea. In fact, it eventually led to the development of all the numerous sledges and hammers we have today. But more than that, out of Pete's Stone Age hammer came other tools, tools for every purpose. This ball peen hammer, for example, is just a practical version of Primitive Pete's first crude invention. But like all tools, there's a right and wrong way to use it. There are still Primitive Petes among us today who would abuse this fine tool. And this would be the horrible result. Obviously, this hammer was never intended for crushing rocks. The ball peen hammer was designed for many purposes. The peen end can be used for riveting. It's also used for shaping soft metal. When using the face, you can avoid damage when hitting a hard object simply by striking with a full face. Never strike the object with the edge. Of course, there are many other types of hammers, all based on the original Stone Age model. There's the brass or copper, the rawhide base, plastic tip, and the claw hammer, which is the most commonly used. Or we should say most commonly misused. To use the claw hammer correctly, rest the head squarely on the nail. Give the nail a slight starting tap. Then drive it in with steady blows. A long nail can be pulled part way with the natural leverage of the claw. Then a block of wood placed under the head will increase the leverage, making a stubborn nail easier to pull, with less strain on the handle. A hammer with a loose head can be plenty dangerous. Here's how Primitive Pete would tighten the head on his hammer, but that only damages the handle at both ends. Have you a little beauty like this in your home? A steel wedge is the right answer. Driven into the wood, the wedge spreads the handle to the tapered sides of the eye and holds it tight in both directions. Gripping the handle too close to the head reduces the force of the blow, and sometimes makes it difficult to drive a nail in straight. Always grip the handle close to the end to increase the length of the lever arm and make each blow more accurate and effective. Never use a handle for a crowbar. That's going all the way back to Primitive familiar tool that takes an awful lot of abuse is the ordinary screwdriver. Our modern-day primitive Pete often uses a screwdriver to pry open a stubborn window. Well, maybe he'll succeed in ruining the tool. This never would have happened if Pete had known more about the screwdriver. It's made up of three principal parts: handle, shank, and blade. Some screwdrivers have a full-length shank extending through the handle. But many household screwdrivers have a shorter shank, pinned to the handle in this fashion. This type will not stand the primitive Pete treatment. The best rule is never hammer on any screwdriver. Many of us try to use one screwdriver for every size of screw head. Always choose a screwdriver with a blade equal in width to the length of the slot. Another thing, never attempt to turn a tight screw if there is too much play between the blade and the slot. A bad fit can cause serious trouble. It can ruin the screw slot or the blade. This looks like the work of primitive Pete. Well, so it is. Fortunately, if the blade is not too badly chipped, it can be reground into serviceable shape. First, grind the tip straight and square with the shank. Then grind each face a little at a time, but never allow the blade to become hot. Excessive heat will draw the temper and the blade will become soft. Here are the front and side views of a properly ground screwdriver. Here's a little trick. If the faces of the blade are tapered in slightly, a short distance back of the tip, the screwdriver will stay down in the screw slot, even when a severe twisting force is exerted. Here is a special type screwdriver designed for heavy duty. The extra-large square shank will stand a wrench if added leverage is needed. Don't be a primitive Pete and resort to the use of pliers. They're apt to chew up the shank. Pliers are made for other purposes. Here are some familiar types: combination, diagonal cutting, long round nose, and side cutting. These side cutting pliers are used chiefly for electrical work. To make an electrical connection, first cut the insulated wire to the required length. Then use the parts back of the joint to flatten the insulation, like this. Then grip the insulation with the cutting edges without biting into the solid wire and strip off the insulation. Now right here is where long round nose pliers come in handy. To make a neat loop to fit a terminal, first use the tip of your pliers to make a right angle bend. Then grip the wire farther out and turn the end into a loop. These diagonal pliers have their cutting jaws at an angle. They're very useful for removing and installing cotter pins. A drop of oil every now and then is good insurance against rust. Like all tools, pliers should be kept in good working order. These combination pliers, equipped with a slip joint, are very commonly used. They usually usually have a small shear between the teeth and the joint for cutting wire or nails. Think of these pliers as a set of extra, stronger fingers, valuable for all sorts of jobs. They should not be used to tighten or loosen nuts. The jaws might slip, chewing off the corners of the nut. A better tool for this job would be an open-end wrench. They usually come in sets, with openings ranging in size from 5/16 of an inch to 1 inch. Wrench measurements refer to the distance between the jaws. Use a wrench that always fits the nut exactly. Pushing on a wrench when the nut is tight is bad practice. Better not, Pete. We're warning you. Some people have to learn the hard way. On open-end wrenches, the head is set at an angle to the handle, usually 15 degrees. This permits efficient use in close quarters. For example, this nut has very little swing space around it. To start the nut, the wrench will fit one set of flats in this position. And we can give the nut a partial turn before the handle jams against the block. But if we try to repeat the action, we find the nut is in a new position and the wrench won't fit. So we flop the wrench over and get a new fit on the nut. Again, we pull the handle as far as it'll go. We keep repeating the procedure until the job is finished. An ingenious development of the open-end wrench is this type. Its adjustable jaw makes it handy for many sizes of nuts and bolt heads. But the jaw should always be set for a snug fit on the side of the nut before exerting any great force. To use the wrench correctly, the pulling force should be applied to the stationary jaw, like this. Great force applied to this weaker adjustable jaw might ruin the tool. This type of wrench is not intended for hard surface, so don't overstrain it. And remember to keep the moving parts well oiled. There are many uses for a medium-sized monkey wrench. This tool also is often abused. The jaw should always be adjusted to a tight fit. And remember to exert the pull on the right side, opposite the opening. If the wrench is used the wrong way, it might slip off the nut and do a lot of damage. See what we mean? Trying to force a stubborn nut by hammering on the handle of the wrench is a sure sign that you're a primitive Pete. If you really want to ruin a good tool, try this on your monkey wrench. You can ruin yourself, too. What Pete needed was a bigger wrench. And we should remember that there is a proper tool for every job if we'd only take the trouble to use it. Pipe wrenches are used for turning pipe fittings, and other round objects. The teeth of the pipe wrench will not grip the fitting unless the tool is worked in the correct position. For best results, the bite should be taken at the center of the jaw. Remember, the teeth will always leave their mark on the work. However, if you must use a pipe wrench on plated fixtures, you can first wrap the pipe with a leather strap. This will protect the finish. A popular wrench with mechanics is the box wrench, designed for use in close quarters. The 12 notches in the head of this tool make it possible to get a good fit over the nut in almost any position. Notice the nut is gripped at all 6 corners. To ensure a working clearance, the head of this wrench is offset from the handle at a 15-degree angle. Some mechanics call this tool a knuckle saver. Here's a combination of a box and open-end wrench, sometimes called a half and half. The box end is ideal for breaking loose a tight nut. Then, if there's no clearance for a full spin, the open end may be used to turn the nut off more quickly than the box end. Every workshop should have a set of socket wrenches with at least one handle to fit the different sockets. However, a quick mechanic needs a larger set, like this one, with a dozen sockets and several handles for different types of jobs. These special handles provide leverage in almost any position. For example, this hinged offset handle can be worked at various angles. This T-handle with a universal joint allows use in very confined areas where it would be difficult to work with ordinary handles. A further improvement is a ratchet handle. With this tool, the ratchet lever can be set so that the wrench pulls in either one direction or the other and ratchets in the opposite direction. When Primitive Pete attached a simple handle to a piece of rock, he became the inventor of the first hand tool known to man. And from this beginning, through centuries of trial and error, came the vast array of fine tools we have today. Most of us take our modern tools for granted, not realizing what a vital part they play in our daily lives.
In a nuclear attack on this planet, one of the greatest threats would be radioactive fallout. While heat and blast effects, even the largest bomb, would have definite impact, any area would be threatened by fallout. The large number of weapons that probably would be dropped in this area would produce fallout, ranging from light to intense over much of the nation. Weapons exploded close to the earth caused the greatest fallout. Thousands of tons of earth particles are drawn upwards into the ascending mushroom cloud, where radioactive particles from nuclear explosions contaminate. These particles are carried by high-altitude winds for many miles. Eventually, they settle to earth, and this is called radioactive fallout. We are all subjected to radiation from outer space and from radioactive material in the Earth's crust. We are exposed to it, the doctor x-rays us, and on many other occasions. Radiation is small or controlled, in fact, are not dangerous. But in large amounts, the amounts produced by nuclear explosion, radiation can make you seriously ill or even killed. Radiation produced by nuclear weapons presents a revolutionary threat to our lives. In an enemy attack, it could become a direct threat to us all. Fortunately, there are means of protecting ourselves, means so effective that civil defense officials use every not have to touch to endanger. Their deadly rays penetrate any kind of medium. But the material through which they pass absorbs part of the radiation and produces testing. Your safety depends upon putting a sufficient mass between yourself and the floor. Concrete, brick, earth, or sand are the best. Any heavy material will do. Civil defense officials recommend that everyone prepare shelter. In most areas of the country, you would receive ample protection from the base of the shelter, constructed of 8-inch concrete wall. This provides the same shielding as 12 inches of earth, 16 inches of wood, or 30 inches of wood. To be certain of adequate protection, shielding should be that equivalent to 3 feet. Civil defense officials recommend for the best fallout your family has used 2 tanks, an approved fallout tank, and enough supplies to enable you to stay in it for a maximum of 2 weeks. Within that 2-week period, it is estimated that community resources will have been restored to some kind. Short-time labor assistance should be available from the state and federal government. Get started right away in protecting your family from the fall. Plans for approved shelters are available from your civil defense officials. Some of the shelters you can build yourself. More elaborate models can be undertaken by a contractor. Let us look at 5 shelters developed by the Office of Civil and Defense Mobilization, any one of which will provide good fallout protection for your family. First, the wasteland concrete block shelter is specifically designed as a field receptacle. The cost will vary according to your area. It could range between $150 to $200 per period. It would provide all the protection needed in most areas. You must be sure the shelter is capable of ceiling will be built capable of holding 2 layers of concrete block. Plans incorporate new home construction. In all of these shelters, you must be sure to use solid concrete blocks rather than a hollow block. Hollow kind will not be adequate shielding unless they are filled with cement, sand, or earth. The second recommended shelter is the above-ground double wall shelter. It is an outdoor above-ground shelter. Also may be built with concrete blocks. It is ideal for regions where water or rocks are practically built underground. Most people would want to hire a contractor to build it. Materials will cost about $700 plus the contractor fee. Virtually absolute protection from fallout is furnished with double wall construction, 20 inches of earth deep, and the 6-inch concrete ceiling covered with 20 inches of gravel. Third, a 3-shaped metal shelter made from 3-shaped corrugated metal sections or precast concrete can be constructed either underground or above ground. This shelter is also suitable for regions where rock or water are close to the surface. When covered with 3 feet of earth and given a protected entrance, it also will provide almost absolute protection. Cost, like the double wall shelter, is about $700 plus the fee of a contractor. Probably would be needed to build it. Number 4, underground concrete shelter will be built by contractors for about $1,000 to $1,500, depending upon the type of fencing used. Plans are designed so that it can have either a stairway entrance, such as is shown here. built with a roof at ground level, mounded over with earth, or it can be built below ground level, or into an embankment. Last, concrete basement shelter is similar to the underground concrete shelter, except that it is designed as an added room to the basement, either in an existing home or one under it. The shelter would add about $500 to the cost of a new home and would be excellent fallout protection. In construction of any one of these shelters, 4 essential features must be included. The first is proper curvature. It must have at least one right-angled curve. Radiation travels in straight lines, only a fraction of it is scattered by the air or materials. So the sharp curve adds to the heat. The second necessity is ventilation. This is provided in a concrete block basement shelter by densely walled and open entrance. The blower may be installed for added heat. In other shelters, vent pipes and the blower is essential for proper ventilation. Good radio reception, next essential, is fielding your heat down. As soon as the shelter is completed, check the radio reception capability. Probably will be necessary to install an outside entrance to receive contact from like this gas pipe. The Civil Defense Shelter book will show him how to make a simple electrical system. This will furnish adequate low-level light without a spare battery. You will also want flashlight or electric lantern for brighter light as needed. After your shelter is finished, you should stock it with provisions for the person you will need for a 2-week stay. Since radiation outside may keep everyone inside, it is important to have adequate supplies of your shelter. In choosing foods, place emphasis on those which require no refrigeration and little cooking. Foods in cans or jars will stay in good condition 6 or more months. Dry, temperature between freezing and 70 degrees Celsius. Goods in paper boxes may be kept for 6 months if they are stored in tightly closed metal cans with the same dry, moderate temperature. Ensure they are in a spot where rodents and insects won't happen. Plan meals so there will be no wreckage, thus eliminating the problem of lack of storage. Meat, poultry, fish, vegetables, fruit, and many other items expected in suitable quantities in such a manner. It is a good practice to rotate canned foods at least once or twice a week. Change those in unprotected paper boxes at least every 3 weeks. Don't forget foods for infants, elderly persons, diabetics, and others who might require special ensure that you choose foods which fit the preferences of your family. Civil defense officials have sample menus showing the quantity of food set aside for each person and week. Use this as your guide. Water will also be an important item. You will need a minimum of 1/2 gallon per day. It can be stored in clean containers, preferably jugs, bottles, or jars, tight fitting. Water in the hot water tank can also be used very close to the shelter. Containers should be cleaned and once every 3 months. Keep the water out. Water purification tablets should be on hand to treat water that might contain harmful bacteria. For cooking and serving, you will want 1 or 2 pans, disposable utensils, all members of the family. A first aid kit will be very helpful. Your civil defense official will list the basic first aid items you might need. You should also have a fully supplied special medicine and equipment for the sick and for chronic conditions, such things as insulin and hypodermic needles. If you have a baby, remember to include powdered formula and milk, bottles, nipples, disposable bags, pins, pouches, and provide sanitation supplies, pads, bibs, bottles, and a receptacle which may be used as a toilet. Don't forget such things as towels, toilet, sanitary napkins, and soap. 5% DDT each Remember how hard it is to keep children entertained on a rainy day. Maintaining a high water in your shelter. Water. Transport. Ramen soup. Coke. Fish sauce. Fruit. Other ingredients. You will also want miscellaneous pallet, box and candy, screwdriver, rubber gloves, chocolate, also and pen. More information on supplies and equipment, together with information on the approved fallout shelter contained in this book. Use it as your guide in planning and stocking your shelter. Now let's suppose for a moment you can't get to the shelter in an emergency. What do you do to protect yourself? First, look for a basement. One below ground level with cut radiation to 1/10 of the level outside. Take a spot in the corner which is least exposed to winter, deepest below the ground. If there is adequate warning, you can improve a basement's protection substantially, locking the windows, breaking dirt, books, magazines, or other hidden materials. If you are in a house with no basement, the best protection will be found in the ground floor, the central part of the house. The radiation there will be about half what it is outside. Large buildings such as apartment houses and offices afford excellent protection. Thick walls and heavy floors will provide almost perfectly protection. Constant lockdown represents prevention. You can agree to the use of fallout particles. Bathe thoroughly. Keep the water outside. Outer garments all fit the temperature. Wash thoroughly before washing and soaking clean. Wash this allowed. Fallout may be the primary threat which places us in a national emergency. Keep in mind that it is a mandatory. Might use now you and your loved ones. You will need a good shelter, 2 weeks supply of food and water, and other living essentials. You have them ready, learn a few safe precautions. You and your family stand a first-rate chance of surviving any nuclear attack. Talk to your local or state civil defense officials immediately. They will give you detailed instructions on what you need to do. Then do it. Then you can rest assured that no matter what the fallout threat in the future, you and your family will be ready for it.
what to do to protect yourself against it. Everybody needs to know. Yes, this does mean you. Watch and listen. One day, these facts may save your life. What is this fallout anyhow? Just bits of radioactive fall out of a mushroom cloud from nuclear explosion and settle on the ground. These bits of matter can be dangerous. You're exposed to some radiation every day, from cosmic rays or other natural sources of radiation. These exposures are too small to hurt you. But when a wartime nuclear explosion occurs, a serious fallout follows. Thousands of tons of atomized earth, building materials, rocks, and gases may be thrown into the air. The mushroom cloud containing them sometimes moves as high as 100,000 feet, nearly 20 miles up. Some of the radioactive particles spill out near the explosion site. Others may be carried for 10, 50, 100 miles or more. But how will you know if there is fallout? You can't hear, smell, taste, or see the radiation. But you yourself can detect the fallout particles that produce it. The easiest time to do this, without special instrument, is when the fallout is settling through the air. This starts any time from about 1/2 hour to several hours after the explosion, depending on how far away you are. And it continues to fall for an hour or longer. Usually you can see the fallout. So if there has been an explosion of a nuclear weapon within a few hundred miles, you should suspect every unusual concentration of dust in the air of being fallout. After an explosion in daylight, watch any unusual accumulation of dust. At night, put a white or light-colored plate outside. Examine it every 15 minutes or so. If dust is accumulated on the plate, treat it as fallout. The particles in that fallout behave like miniature X-ray machines, sending out radiation in all directions. If there are many particles, and if you are exposed to them long enough, you will be hurt. Others will be watching for that fallout, of course. Experts will estimate the probable path and speed of approaching fallout and try to keep you posted. But it may come before you hear any details by radio or otherwise. You must take precautions, whether you hear their reports or not. If radio stations are operating, you will hear reports, especially on the Commonwealth frequencies 640 or 1240 on your AM dial. As soon as it is safe for specially protected crews to get out into the open, these highly trained civil defense radiation detection teams will make a thorough check of radiation levels and characteristics. Those facts will be relayed to you by radio as fast as they come into civil defense headquarters in your area. Information from the radiation monitoring team will be combined and analyzed by experts manning a central radiation control point. These experts, who know just how fast harmful radiation reduces in force, can predict when it will be safe for people to come out of shelters and resume normal tasks. We have warned that you may have to act before you get any detailed report. Just what can you do if fallout comes your way? Find the best shelter you can. The more solid substance you can put between yourself and the fallout, the better. But an ordinary frame house with windows closed will give considerable protection. In a house, it's best to get on the floor, away from doors and windows. Or if you can, find a location with additional walls in the center of the building. A basement is even better if the house has one. Large buildings, such as apartment or office buildings, give good protection. The thick, heavy masonry of their walls and floors makes it hard for radiation to get through. Basements, inside rooms, or corridors on the lower floors are safer. The basement of any house or building will become a good improvised shelter if you block the windows with sandbags and place other sandbags on the floor above the shelter area. If you don't have sandbags, thick, solid layers of books, magazines or newspapers, or even a series of file cabinets standing close to each other can cut the radiation danger. In some parts of the country, there are storm cellars or outside vegetable storage cellars. They may be used as shelters from fallout. If you plan to use such a cellar, or your basement, or any other shelter, start it with food and supplies. To equip and supply your shelter area, you need some of the same things you might take on a vacation camping trip. First, sleeping equipment to fit your shelter area. Folding cots, or sleeping bags, and blankets. Then, food and water. There should be at least a 2-week supply. You want plenty of fruit juices and lots of your family's favorite canned food. The drinking water supply should be rotated often to be sure it's fresh. Don't forget such basic needs as sugar, salt, pepper, and other seasoning that your family ordinarily uses. Now, some equipment. A radio is very important. It should be a battery portable with spare batteries. A transistorized radio is best. The batteries last longer. Next, you need light in the form of flashlights and a battery-operated lantern. Then, a good first aid kit. Now, plates, cups, silverware. A can opener and a bottle opener are important. Add to these things enough closed containers to take care of garbage and human waste. Especially if there will be children in the shelter, include some books and magazines, paper and pencils, maybe 1 or 2 small, simple games. The best protection of all is the special shelter built according to specifications of your local civil defense organization. This has an air filter to allow ventilation, but keep dust out. It has at least 3 feet of earth over it. It would be a good idea to go right now to your local civil defense office to secure plans for the type of shelter you want. Then, to get busy on construction. Plans are simple, using standard materials. So maybe you can do the job yourself. But all this special shelter talk won't help very much. You are caught way out on the open road. If that happens, keep driving until you see a building, maybe a house or barn, church or school. Drive as close to the building as you can. Then get yourself and your family out of the car and take cover in the building. If you live on a farm and have sufficient warning, get your animals under cover and give them enough food and water to last several days. And if you can, cover any piles of hay or harvested crop that may be outside. If the explosion has been some miles away, you will have time to fill tubs and other containers with water before fallout arrives. All locations where outside dust does not penetrate will be safe storage points for water. Whatever kind of shelter you find, settle down and make the best of it. If there are others with you, help them by being as calm as you can, and don't be discouraged. You can go out for very brief periods if you are well covered and keep the dust off your skin. Wear heavy boots or shoes, and pants tucked in or tied around the bottom. Keep dust out. If any dust gets on you, brush it off promptly. When you have a chance, wash it off. That dust can burn your skin. But what happens if you do get exposed to a great deal of fallout? Food or water has been contaminated by the dust. Internal damage may occur. When dust has been left on skin, there will be skin burns. When you have been near dust too long, there may be radiation sickness. Exposure can even cause death. If you have had considerable exposure, you will vomit and grow weak. But after a few hours, this sensation will pass. By the next day, you may have had the last of it. Even if you have been exposed to excessive fallout, you may eat and drink just as you normally would. But don't force yourself. Whether you have had these symptoms or not, if civil defense radio announcements have said that radiation has been high in your section, keep an eye on your condition for the next few days. Watch especially for these developments in the 2 weeks following exposure. Return of nausea, sore throat, bruise spots developing without any known reason, loss of hair. These conditions, or nosebleed, or diarrhea, should be reported to a doctor or to the nearest first aid station set up under civil defense plans. Unless civil defense teams have warned that your area is still dangerously radioactive, you can get out and work to help yourself and help others. Although fallout can be deadly, your chances of avoiding damage from it are much better if you follow the directions we have given you. During an alert, keep your portable radio tuned to the Commonwealth radio frequencies, 640 and 1240 on the AM dial, for the latest reports and advice. Right now, today, before there is an alert, take time to learn the Civil Defense 5 steps to safety. Learn warning signals and what they mean. Learn your community plan for emergency action. Learn protection from radioactive fallout. Learn first aid and home emergency preparedness steps. And learn how to use Commonwealth 640 or 1240 on the AM dial for official directions.
scientist has been forced to acquire many novel techniques to absorb a variety of concepts. Radioisotope becomes useful to the scientist only when these concepts have taken their places in an orderly structure of method and underlying theory. The first concept of science those which have to do with the nature of matter, the dynamics of its smaller components. Now it is known that the atom, considered the basic unit of matter, is itself a void, in which planetary particles called electrons revolve in great orbits around a central nucleus. The nucleus also has a structure composed of protons and neutrons. Each proton has a weight of 1.00758 atomic mass. The neutron is slightly heavier. In the usual notation, the mass is shown in round numbers, one for both proton and neutron. The proton carries 1 unit of positive charge, indicated in subscript. The neutron has no charge. Electron has 1 unit of negative charge. Its mass is insignificant compared to that of a proton or neutron. Again, charge is shown in subscript, mass in superscript. In describing an atom, the same notation is used. The atomic number of the element, subscript, is equal to the number of electrical charges carried by the protons in the nucleus. The mass number in superscript is equal to the sum of protons and neutrons. Designation for helium is 2 in 4. Normally, the positive charge of the 2 protons in the nucleus is balanced by the negative charges of an equal number of orbital electrons. Atoms can be classified according to the number of protons in the nucleus, by the atomic number, and according to the number of neutrons. In terms of proton number and neutron number, it is possible to define any atom. Normal hydrogen atoms have 1 proton and no neutron. Helium, with 2 protons, usually has 2 neutrons. Lithium, has 3 protons and 4 neutrons. And so on. The other atoms are identified according to the same system. The number of protons, or the atomic number, identifies the element. All atoms of the same element have the same number of protons. However, in most elements, there are found atoms with different neutron numbers. These different forms of the same element are isotopes, atoms of the same element, alike chemically, differing only in the number of neutrons. The sum of protons and neutrons gives the mass. Atom of helium, which has 2 protons and 2 neutrons, has a mass of 4. Lithium atom, with 3 protons and 3 neutrons, has 6 masses. Different isotopes of the same element have different masses. They have a different number of neutrons. Again, to complete the description of each atom, the element was accompanied by its atomic number in substance. Elements have 2 or more isotopes. However, a few have only 1. For instance, cobalt, element number 27, has only 1 natural isotope. All cobalt atoms found in nature have the same atomic weight, 59. Therefore, the same number of neutrons. However, most elements have more than 1 natural form. Zinc, number 30 on the chart, has 5 natural isotopes. Zinc, as in most elements, the number of neutrons
greater than the number of protons. The number of neutrons can be found by subtracting the proton number from the atom. Higher on the chart, a few additional elements have only one isotope, though most have several. At higher atomic numbers, the ratio of neutrons to protons becomes greater and greater. The natural isotope of mercury, the lightest atoms have 114 neutrons, 36 more neutrons than protons. The heaviest have 124 neutrons, 44 more neutrons than protons. To illustrate neutron-proton ratio, the isotopes can be plotted on a graph of atomic number against neutron number. In this graph, a straight diagonal line would intersect all points at which proton number equals neutron number. However, if the isotopes found in nature are plotted on this graph, it is found that they depart from the diagonal. In other words, they have a preponderance of neutrons over protons. A preponderance which tends to increase at higher atomic numbers. With a few exceptions, these positions represent atoms with stable neutron-proton ratio, capable of existing indefinitely without any observable change. The empty spaces represent neutron-proton ratio, which will not be stable. It is reasonable to assume that if an atom existed in an empty space on the chart, it would show a tendency to change itself to an atom having a more stable neutron-proton ratio. For instance, an atom occupying a position above the natural isotope would have a disproportionately high ratio of protons to neutrons, and would tend toward the position of one of the naturally stable isotopes below it. Similarly, an atom having a disproportionate excess of neutrons over protons would tend to take a position of one of the naturally stable isotopes above it. This illustrates one of the primary principles of nuclear stability: the tendency of all atoms to reach an equilibrium in terms of a stable neutron-proton ratio. Up to atomic number 83, the natural isotopes are stable, with a few exceptions. However, above atomic number 83, all the isotopes are unstable. They all have a disproportionate number of neutrons, many or few. Without exception, these isotopes are radioactive, and return to stability through a process known as radioactive decay. For example, uranium, the heaviest element found in nature, has 3 natural isotopes. Each uranium isotope tends to return to stability through a series of transformations ending in a stable normal state. An example of this process is the way in which uranium-238 changes to lead-206. Transformation from instability to stability is a complex process which takes place in a series of separate steps. The first step occurs when the uranium atom throws off a nuclear particle of 4 mass units composed of 2 protons and 2 neutrons. This single unit is known as an alpha particle. In this change, the uranium-238 atom becomes thorium-234, which has 2 less units of charge on the nucleus and 4 less units of mass. The nucleus of the thorium atom emits an electron, which possesses a negative unit of charge and negligible mass. This electron, thrown off by the nucleus of the thorium atom, is known as a beta particle, and is usually represented by the Greek letter beta. With this emission of a negatively charged beta particle, thorium-234 in turn changes to protoactinium-234, and atom with 91 instead of 90 on the nucleus. Protoactinium-234 throws off increasing atomic number by 1, thus changing to uranium-234. Uranium-234 next throws off
complex series of nuclear transformations has taken place from an unstable neutron-proton ratio to a stable state. In every step of radioactive decay, the transformation is from parent to daughter, and parent to daughter. Atoms of the parent element decay to produce atoms of the daughter element. The same terminology applies whether or not the transformation is to a higher or lower atomic number. There is no way of foretelling when any particular unstable nuclear decay from one sample to the next. However, in any sample of a radioactive isotope having millions of billions of atoms, some of the atoms are always in the process of decay. The number of atoms decaying in a unit time in a sample of radioactive isotope is called the activity of that sample sample. Activity, or rate of decay, is generally stated in terms of millicuries, or MC for short. A given sample of radioactive material is said to have an activity of 1 millicurie when 37 million atoms decay or disintegrate per second. Millicurie is the commonly accepted measure of radioactivity. Decay from a parent isotope to a daughter isotope can therefore be illustrated in terms of the number of unstable atoms at the time. On this graph, the number of unstable parent atoms that exist at any given instant can be represented by a point. Since the parent substance is decaying, fewer unstable parent atoms will be present at any later time. In the language of simple calculus, the number of parent atoms has decreased by delta n during a time
roughly 5,700 years. Or take the case of uranium. U-238 has a half-life of 4.5 billion years, giving a straight line on a graph calibrated in terms of daily time. In contrast to the long half-life of U-238, thorium-234, the daughter of U-238, has a half-life of 24.7 days. Thus, while all steps of decay are unpredictable to a single atom, the statistical rate of decay in a large number of atoms can be predicted and measured with great accuracy. Examining the various steps of the decay series, beginning with U-238, it appears that there are at least two ways in which unstable atoms can change to a more stable form. By throwing off an alpha particle, losing 4 units of mass and 2 electrical charges. Or by throwing off a beta particle and increasing atomic number by 1. In the process of decay of U-238 to stable lead, each of the two types of transformation occurs several times. In 8 steps of decay, 8 alpha particles are given off. 6 beta particles are emitted. One would assume that these 14 particles would account for the mass difference between uranium-238 and lead-206. Let's check this. The exact weight of an alpha particle is known from accurate determination. The 8 alpha particles thrown off weigh 32.02 units of mass. The mass of beta particles is also known with great accuracy. Adding the weight, it is found that 32.025 units of total mass have been given off as discrete particles during the decay process. But if the weight of lead-206 is subtracted from that of uranium-238, we find that the total mass lost in the decay is somewhat greater than that represented by the alpha and beta particles thrown off. In other words, 0.045 units of mass are unaccounted for, representing a minute fraction of a gram. According to Einstein's formula, energy and mass are equivalent. In solving the formula, it is found that this mass represents a really significant energy. In the transition from uranium to lead, this energy has been released in addition to the alpha and beta particles. Most of this energy, released during uranium decay, has been applied in giving the ejected particles their high speed. In other words, as kinetic energy. Additional energy is also released as a form of electromagnetic energy known as gamma radiation. To summarize, the decay of uranium-238, resulting in stable lead, accompanied by the release of alpha particles, beta particles, and gamma radiation. This is generally true. Change from instability to stability is accompanied by energy released as discrete particles or electromagnetic radiation, or both. It is the energy released by the decay of uranium in uranium-bearing ore which makes it possible to detect it with the Geiger counter, even though mixed in minute proportions with a variety of other substances. The decay series, beginning with uranium-238, is only one of several. A similar decay scheme begins with U-235, another with thorium-230, another with thorium-232. Uranium and all the unstable elements near it on the chart have very long half-lives, which have
permitted them to survive from an early age of greater radioactivity. They are fated by the inevitable process of decay to return in time to a stable state. Lower on the scale of elements are found a few unstable survivors. Naturally radioactive isotopes with long half-life, such as rhenium-187, cesium-176, tin-124, rubidium-87, and potassium-40. All of these return to stability in a stable state. Potassium-40 offers a good illustration of the three possible modes of nuclear transformation. One possibility, potassium-40 may give off a beta particle, increasing its nuclear charge by 1, and changing to calcium-40. In this case, the beta particle is accompanied by excess energy as a gamma. Or potassium-40 might emit a positive electron, reducing atomic number to become argon-40. A positive electron is known as a positron. As the third possibility, the potassium nucleus may absorb an electron, becoming argon-40 without emitting any discrete particles. In all three cases, there is a change in atomic number without any significant change in mass. The sum of neutrons plus protons remains the same. Obviously, each change must involve a shift in the neutron-proton ratio in the nucleus. For example, when potassium-40 changes to calcium-40, one of the neutrons in its nucleus has become a proton and an electron. In other words, a neutron of zero charge in one mass unit has become a proton of positive charge in mass 1, and an electron of one negative charge in very slight mass. Mass and charge units are conserved. When potassium-40 emits a positron, changes to argon-40, a proton in the nucleus has changed to form a neutron and a positron. This type of nuclear change is called positron decay. In the third possibility, one of the protons in the nucleus may join with an electron to form a neutron. This transformation would seem contrary to logic. It is generally assumed that there are no free electrons in the nucleus. Such a phenomenon can best be explained by referring to the nucleus and its surrounding electrons. It sometimes occurs that an electron from the inner or K shell is captured by the nucleus and is immediately absorbed by a proton. The opposite electrical is released as positrons, beta particles, and gamma rays, and in K-capture as X-rays. In potassium-40 decay, positron emission is difficult to substantiate, occurring rarely if at all. In K-capture, the X-rays emitted are of low energy, difficult to measure. In other radioisotopes, any of these radiations may be given off in different proportions and relative energy. Decay and emission of energy as radiation occurs in all radioisotopes. However, uranium-235 and one or two other radioisotopes have a second and unique characteristic. If it were possible to observe a single atom of uranium-235 penetrate through the electron shell of the star, it would appear to be in a constant state of agitation. In all probability, it would throw off an alpha particle as the first step in the decay process. However, in a gram of U-235 per second, at least one atom behaves quite differently. It becomes more and more unstable until it splits into two fragments, each a lighter atom of lower atomic number. In addition, two or more neutrons are left over in the reaction. This is the reaction of spontaneous fission. In a single fission, taking place in a minute fraction of a second, considerable energy is released, about 4 times as much as in all steps of the long decay process of U-238 or lead. Part of the energy is kinetic energy, giving velocity to the neutrons in the two fragments of uranium. The remainder of the energy is given off as gamma radiation. And beta radiation. In uranium fission, 1 to 3 neutrons are emitted. If enough uranium atoms are present, one of the neutrons may strike and be absorbed by another nucleus of U-235. With the added mass, this nucleus is very fission, releasing still other neutrons, and the process continues. This is a chain reaction, such as that which takes place in an uncontrolled manner in the atomic bomb. However, if uranium fission occurs in uranium mixed with some light substance such as graphite, the neutrons are slowed down by collision with the carbon atom. Because of its slowing action on the neutrons, the graphite or other light substance is known as a moderator. The neutrons, because of their reduced velocity, are much less likely to escape from the uranium and are much more likely to penetrate the nuclei of the uranium atom. The amount of uranium is not material. A large proportion of it will escape. The reaction will die out.
соответствии с программой испытаний новых образцов водородных зарядов 30 октября 1961 года был произведен взрыв чистой водородной бомбы с тротиловым эквивалентом 50 миллионов тонн. Новый водородный заряд разработан большим коллективом ученых, конструкторов и изготовлен на предприятиях министерства. При испытании заряд был смонтирован в корпусе авиационной бомбы, способной вмещать заряды мощностью 100 миллионов тонн и более. Взрыв намечалось произвести на большой высоте над землей с использованием самолетов. В хвостовой части бомбы предусмотрено место для установки парашютного. Для транспортировки в собранном виде изделие было помещено в особые железнодорожные вагоны. Стенки и крыша вагона разборные. К месту назначения изделие было направлено специальным поездом. При следовании поезда были приняты все необходимые меры безопасности. Для подготовки бомбы к испытаниям и подвески ее в самолетах был выбран один из аэродромов дальней авиации военно-воздушных сил, расположенный на Кольском полуострове. Сюда прибыл поезд с изделием. На железнодорожной станции аэродрома хорошо оборудованная погрузно-разгрузочная площадка. Все разгрузочные операции производились по намеченному заранее плану. После завершения разборки вагона железнодорожному составу подан автомобильный поезд. И изделие было перегружено на автоприцеп для дальнейшей транспортировки. Проверка и подготовка изделия к испытанию производилась в специальном здании. Здесь детальному и строгому техническому контролю был подвергнут каждый узел изделия, каждый элемент его автоматики. В момент срабатывания заряда имеют значение даже миллионные доли секунды. Поэтому элементы автоматики, телеметрические датчики и передающие устройства должны быть настроены на заданную программу с абсолютной точностью. Проверка узлов изделия подходит к концу. Устанавливаются на свои места съемные части бомбы.
подготовлена для вывода. Одновременно с подготовкой изделия производилась подготовка тяжелого бомбардировщика дальнего действия «Амbience», способного нести бомбу весом 26 тонн. Весь корпус самолета и даже лопасти его винтов окрашивались высокой защитной краской, предохраняющей от светового действия взрыва. Для определения теплового и ударного типа самолет устанавливается исключительно. Специально оборудованный самолет-лаборатория должен сопровождать самолет. На борту этого самолета были размещены приемная радиотелефоническая аппаратура, самописцы давления состава, осциллографы администрации мощности взрыва по минимуму значения. Аппаратура для записи показателей приборов на магнитную ленту. Снаружи крепились камеры для съемки взрыва. Устанавливались калориметры для замера тепловых потоков. Узел связывали его положение. Аппаратура для радиотелефонных переговоров. Автоматическая радиостанция – одна из самых мощных на севере нашей страны. Все это позволило организовать систему надежной дублированной связи между пунктами, обеспечивающими проведение испытания, которые находились на значительном расстоянии друг от друга. Государственный испытательный полигон номер 6 Министерства обороны СССР, на котором должен был производиться взрыв бомбы, расположен на Новой Земле. Район Белушки и Губы – основная база полигона. Здесь размещается штаб научных подразделений, лаборатории и вспомогательных служб. На период испытаний в Белушке была сосредоточена группа приборов морского обеспечения. Объединенный командный пункт руководства испытаний находился в подземном сооружении. Здесь большой радиотелеграфный и радиотелефонный пункт. Его задача входила поддерживать двустороннюю связь с расположенным на территории полигона с аэродромом Сольский завод, с носителем управления его проектом. Расстояние от командного пункта в Белушке до опытного поля 250 км. Значительно ближе находилась площадка Т-8. От нее до опытного поля 90 км. Эта площадка использовалась для подготовки и управления автоматической измерительной и регистрирующей аппаратурой, размещенной в районе взрыва. Средством сообщения между площадкой Т-8 и опытным полем служили военные корабли. Оперативные перевозки производились на вертолете. Площадка для сброса бомб была выбрана в той части Новой Земли, где характер местности создавал наилучшие условия безопасности. Задача испытания не входила изучение разрушительного действия ударной волны. Поэтому мы не видим в районе опытного поля специально разбитых зданий, как и какой-либо военной техники. Вместе с тем, здесь было размещено большое число самых разнообразных культур для демонстрации и изменения характера. Осциллографы записи коэффициента размножения нейтронов. Измерители интервалов времени срабатывания автоматических устройств снаряда. Управление аппаратурой, установленной в сооружениях опытного поля, производилось автоматически по радио. Радиосигналы поступали с площадки Т-8. Где в подземном сооружении находился командный пункт службы безопасности. Здесь был установлен программный автомат, выдающий команды на поле нужной последовательности. Как же проходил основной этап испытания? До взрыва осталось несколько часов. Белушин, начальник штаба полигона, принимает доклад о мерах, принятых по выполнению оперативного плана морского обеспечения. В этом плане точно определено, где будут находиться корабли и личный состав полигона в момент взрыва. Подготовка опытного поля закончена. Производится полная эвакуация личного состава и кораблей в безопасную зону. Напряженно работает метеорологическая служба. Составляется карта прогноза погоды. Особенно тщательно изучается направление ветров. В боевой готовности служба противовоздушной обороны. Опасный район покидают последние суда. Принято решение подвесить изделия самолетной. Подвеска бомбы такого размера и веса совсем обычное дело. Но на аэродроме к этому хорошо производится осмотр. Особенно тщательно проверяется укладка парашютной системы. надежность ее работы зависит безопасность экипажа самолета. Для подвески бомбы созданы специальные подъемные устройства. Подъем изделия к самолету плавно и равномерно. Размеры бомбы не позволяют разместить ее в бомболюбе самолета. Поэтому она закрепляется выше под фюзеляжем. Заседание Государственной комиссии по проведению испытаний. Производится оценка общей обстановки, складывающейся в районе испытания к назначенному дню взрыва. Окончательно уточняется трасса и условия полета самолета-носителя. На новой земле еще раз проверяются условия безопасности от последствий взрыва для районов, расположенных вне территории испытательного полигона. Анализ данных, из которых складывается общая обстановка с момента взрыва, дает уверенность в том, что распространение ударной волны будет ограничено, а зона возможных разрушений земной поверхности минимальна. Утро 30 октября. Носитель готов. Последний инструктаж. Командный пункт аэродрома. Приближается время старта. Разрешен запуск мотора. Заработали турбулентовые двигатели. Взлет разрешен. Следом за носителем в воздух поднимается самолет-лаборатория. Самолет-носитель с подвешенной к нему особо мощной водородной бомбой набирает высоту. За ним ведется неослабное наблюдение из различных пунктов на Земле. С экипажем поддерживается непрерывная двусторонняя связь. Десятки локационных станций противовоздушной обороны следят за общей обстановкой в воздухе. Высота 10 500 метров. Экипаж самолета-носителя отлично подготовлен к выполнению ответственного боевого задания. На параллельном курсе самолет-лаборатория. Точно следуя намеченным курсом, самолеты приближаются к новой земле. Теперь управление полетом и связь с самолетами передается командному пункту полигона. Отсюда, по условным таблицам, передаются команды на самолет-носитель. Носитель вышел на боевой курс. Цель видна. Управление сбросом бомбы переводится на автоматику. Сигнал «Сброс». На Д-8 включается программный автомат аппаратуры опытного поля. «Сброс». Экипаж надевает защитные очки. Программный автомат принял сигнал «Сброс» и выдает команды запуска аппаратуры опытного поля. Точно по расчету работала парашютная система. Бомба приближается к точке взрыва. Высота 4000 метров. Осталось 3 секунды. 2, 1, 0. Взрыв сопровождался световой вспышкой необычной силы. В этот момент самолет-носитель находился в 45 километрах от места сброса. Вспышка и последующее свечение, несмотря на сплошную облачность, были видны в радиусе до 1000 километров. Полевой столб, поднимающийся с земли, быстро увеличился в объеме. Через несколько секунд после взрыва диаметр полевого столба составлял около 10 километров. В это же время с самолета, находившегося в 250 километрах от точки взрыва, был виден огненный купол из раскаленных продуктов взрыва. Он медленно поднимался вверх, увеличиваясь в объеме. Максимальный диаметр купола доходил до 20 километров. Пронизав несколько слоев сплошной облачности, огненный купол через 40 секунд после взрыва достиг высоты 30 километров. С этого момента началось постепенное превращение купола в грибообразное облако. Увеличиваясь в размерах, облако медленно поднималось вверх. В своем конечном развитии оно достигло высоты 60-65 километров. Его диаметр равнялся 90 километров. В дальнейшем облако начало утрачивать грибообразную форму. В этот период диаметр его основания был равен 70 километров, а диаметр ножки 26-28 километров. При возвращении на аэродром экипаж самолета-носителя наблюдал облако взрыва с расстояния 800 километров. Через несколько часов после взрыва облако поля вылетел вертолет разведки. В район облачного поля вышли корабли испытательных сил. Вот и опыт. Перед посадкой вертолета проверка на радиоактивность. Даже в самом центре площадки она оказалась незначительной.
техническим группам полигона разрешен выезд в поле. Вспомним, как выглядело опытное поле до взрыва. Теперь его вид сильно изменился. На десятки километров вокруг соленая была среда. Такими входят подземные приборные сооружения. На основе даже самых предварительных данных стало очевидно, что произведенный взрыв является рекордом по своей силе. Вместе с тем выбранная высота и метеорологические условия в момент взрыва несколько раз уменьшили предполагаемую зону воздействия ударной волны. В эту зону входил ряд населенных пунктов. Ни в одном из них не было отмечено каких-либо существенных последствий взрыва. В то же время, даже наиболее отдаленных от опытного поля пункта были отчетливо видны воздушные взрывы, длительное свечение и был слышен звук пришедшей ударной волны. Вся регистрирующая измерительная аппаратура на опытном поле сработала нормально. Полученные данные позволили определить фактическую мощность взрыва, характер ядерной реакции, точность срабатывания автоматики изделия и ряд других факторов. Испытание особо мощного водородного заряда, имеющего ряд новых конструктивных особенностей, подтвердило, что Советский Союз имеет в своем распоряжении термоядерное оружие мощностью 50, 100 и более мегатонн.
what we all must learn to do. You and you and you and you. Duck and cover.
Be sure and remember what Bert the Turtle just did, Ben, because every one of us must remember to do the same thing. That's what this film is all about. Duck and cover. This is an official civil defense film produced in cooperation with the Federal Civil Defense Administration and in consultation with the Safety Commission of the National Education Association. Produced by Archer Productions, Incorporated. Hey, Bert, come on out and meet all these nice people, please. Oh, all right. We really can't blame you. You see, Bert is a very, very careful fellow. When there's danger, this is the way he keeps from being hurt. Sometimes it even saves his life. That's why these children are practicing to duck and cover just as you do in your school. We all know the atomic bomb is very dangerous. It may be used against us. We must get ready for it, just as we are ready for many other dangers that are around us all the time. Fire is a danger. It can burn whole buildings if someone is careless. But we are ready for fire. We have a fine fire department to put out the fire. You have fire drills in your school, so you know what to do. Automobiles can be dangerous too. They sometimes cause bad accidents, but we are ready. We have safety rules that car drivers and people who are walking must obey. Now, we must be ready for a new danger, the atomic bomb. First, you'll have to know what happens when an atomic bomb explodes. You will know when it comes. We hope it never comes, but get ready. It looks something like this. There is a bright flash, brighter than the sun, brighter than anything you've ever seen. If you are not ready, did not know what to do, it could hurt you in different ways. It could knock you down hard, or throw you against a tree or a wall. It is such a big explosion, it can smash in buildings, knock signboards over, break windows all over town. But if you duck and cover like Bert, it will be much safer. You know how bad sunburn feels. The atomic bomb flash will burn you worse than a terrible sunburn, especially where you're not covered. Now, you and I don't have shells to crawl into like Bert the Turtle, so we have to cover up in our own way. First, duck. Then, cover. And very tightly, cover the back of your neck, face. Duck and cover underneath a table, or desk, or anything else close by. In Betty's school, they're talking about the atomic bomb, too. Betty is asking the teacher, how can we tell when the atomic bomb may explode? The teacher is explaining there are two kinds of attacks, with warning and without any warning. We think that most of the time we will be warned before the bomb explodes, so there will be time for us to get into our homes, schools, or some other safe place. Our civil defense workers, our men in uniform, will do everything they can to warn us before enemy planes bring a bomb near us. You may be in your schoolyard playing the signal comes. That signal means to stop whatever you are doing and get to the nearest safe place fast. Always remember, the flash of an atomic bomb can come at any time, no matter where you may be. You might be out playing at home when the warning comes. Then be sure to get into the house fast, where your parents have fixed a safe place for you to go. If you are not close to home when you hear the warning, go to the nearest safe cover. Know where you want to go, or ask an older person to help you. You know the places marked with the X sign? They're safe places to go when you hear the alarm. If there is a warning, you will hear it before the bomb explodes. Sometimes, and this is very, very important, sometimes the bomb might explode without any warning. Then, the first thing we would know about it would be the flash. That means duck and cover fast, wherever you are. There's no time to look around or wait. Be like Bert. There's a flash, duck and cover, and do it fast. Here are some older boys showing what to do if the flash comes when you are not in class. This is what you do. Be in a corridor. You duck and cover tight against the wall this way. Remember to keep your face, the back of your neck, covered tight. Try to fall away from windows.
the table. Then, if the explosion makes anything in the room fall down, it can't fall on you. Getting ready means we will all have to be able to take care of ourselves. The bomb might explode when there are no grown-ups near. Paul and Patty know this, and they're always ready to take care of themselves. Here they are on their way to school on a beautiful spring day. No matter where they go or what they do, they always try to remember what to do if the atom bomb explodes right then. It's a bomb, duck and cover. Paul and Patty know what to do. Paul covered the back of his head so that he wouldn't be burned. Patty covered herself with the coat she was carrying. They knew how to duck and cover. They acted right away when the flash came. They had been at this doorway when the bomb flashed. Paul and Patty would have ducked and covered this way. Heavy doorways are a good place to duck and cover. Gee, would be safer too. Here's Tony going to his Cub Scout meeting. Tony knows the bomb can explode any time of the year, day or night. He's ready for it. Duck and cover. Atta boy, Tony. That flash means act fast. Tony knows that it helps to get to any kind of cover. This wall was close by, so that's where he ducked and covered. Tony knew what to do. Notice how he keeps from moving or from getting up and running? He stays down until he is sure the danger is over. The man helping Tony is a civil defense worker. His job is to help protect us when there is danger of the atomic bomb. We must obey the civil defense worker. We must know how to duck and cover in a school bus or in any other bus or streetcar. Duck and cover. Don't wait. Duck away from the windows fast. The glass may break and fly through the air and cut you. Sundays, holidays, vacation time, we must be ready every day, all the time, to do the right thing if the atomic bomb explodes. Duck and cover. This family knows what to do. Your own family should. They know that even a thin small helps protect you. Even a newspaper will save you from a bad burn. The most important thing of all is to duck and cover yourself, especially where your clothes do not cover you. No matter where we live, the city or the country, we must be ready all the time for the atomic bomb. Duck and cover. That's the first thing to do. Duck and cover. The next important thing to do after that is to stay covered until the danger is over. Yes, we must all get ready now, so we know how to save ourselves if the atomic bomb ever explodes near us. If you do not know just what to do, ask your teacher when this film is over. Discuss what you could do in different places when the bomb explodes. Older people will help us as they always do. There might not be any grown-ups around when the bomb explodes. Then, you're on your own.
Remember what to do, friends. Now tell me right out loud. What are you supposed to do when you see the flash? Duck and cover. Duck and cover.
trouble whatsoever in negotiating the city streets. On the sharpest of turns, however, is where they really prove their mettle. Handled exactly like the biggest pumpkin bladder trucks of any fire department, but some 30 feet longer and many tons heavier, the guns took every twist and turn in stride. They are big, but flexible. Once out of Las Vegas, they settle down to the long grind north to the proving ground. During field operations involving the 280-millimeter guns, they travel in batteries, such as these. A battery consists of 2 guns. 3 batteries make up a battalion. The battalions provide support for field army or separate corps action. There are, with each battery, 9 support vehicles, acting as transport for gun personnel, supplies, and ammunition. In convoy on hardtop highways, the guns can travel at 30 miles per hour, and in spite of their road weight of 76 tons, can use the standard Army bridges wherever necessary. 70 miles north of Las Vegas was the turnout for the firing site. In 1944, when the original design specifications were drawn up, the gun was to have been a 240-millimeter weapon. However, these specifications were soon changed for the rapidly advancing artillery capabilities and the foreshadowing of the atomic age. Instead, were substituted the designs for a 280-millimeter weapon, with not only HE, but atomic firepower. In 1951, the gun was tested as a normal artillery piece at Aberdeen. Needless to say, these tests were successful. All that remained was to check out its other capabilities, the atomic shell. Even on secondary roads or rough terrain, the guns retain relatively high mobility in spite of the fact that their speeds are lowered to approximately 10 miles per hour. The main reason for this mobility are the prime movers connected to the front and the rear of each weapon. Each prime mover is capable of 365 horsepower. Just one of these cabs has 50% more payload than the largest Western highway truck. For a heavyweight fighter, the big guns are light on their toes. Once at the firing site, the line of fire was given, and the guns were directed to their respective emplacements. After getting into position, the rear cab lowers the gun and moves away. And then the front cab uses the tube into the battery and moves away. Unlike field operations of World War II, these guns need no extensive ground preparation. In most cases, there is no necessity for excavation of any kind. The entire 47-ton weight of the gun itself is balanced by a turntable and 3 jacks to hairbreadth specifications. So the total time to prepare for firing, just 20 minutes. After being placed in their firing positions, and prior to the firing of the Mark 9 atomic shell, a series of HE rounds were fired. These rounds serve the purpose of a final check on the many ballistic variables which could affect the accuracy in a given situation. Unlike the standard artillery weapons, which are single recoil mechanisms, the 280-millimeter gun has the advantage of a double recoil action. When fired, it can recoil into the upper carriage, and then the upper carriage recoil. Such a system is the main reason for the lack of ground preparation needed before firing. A folding cloth is used to load the projector and with the pellet. During firing operations, ramming can be done both manually and hydraulically. The gun is capable of a 360-degree traverse and can go to a maximum elevation of 55 degrees. And the time for rehearsals and final checkouts is over now as 0 hour approaches. The big gun is ready to prove atomic punch with the firing of the Mark 9 shell as one phase of Operation Upshot Knothole in the outer air. Everything functions with a precision found in any capable, well-trained team. 0 hour is minutes away now. The projector was prepared and brought to the gun.